तुमने किया हुआ इसमें? नो, वो ड्रॉ करते हुए उन लोग का फोटो लिया था क्या? You do have any pictures like that? नहीं. Okay. Once you ask Vishesh if she has.
मनीष बताओ भैया। नहीं होगा, अच्छा ठीक है। अच्छा ठीक ठीक, ओके, नमस्कार।
Hello. यार हो गई है सब लड़कियां, हम ही हैं जो पता नहीं। हाय, गुड मॉर्निंग।
हेलो मॉर्निंग।
Good morning, ma'am.
आप
गुड
एडमिन
मॉर्निंग।
नाम से हो क्या?
गुड मॉर्निंग मैम।
नहीं, मैं एडमिन, पता नहीं किसने बनाया मेरे को एडमिन।
नहीं, आप किस नाम से ज्वाइन किए हो?
तुमने क्या
आपका नाम
इंटरव्यू?
क्या डिस्प्ले हो रहा है नाम?
कुछ एडमिन डिस्प्ले हो रहा है, बट इट शुड बी चेंज।
मैं चेंज कर दे रही हूँ।
चेंज कर दो, नाम भी डाल दो आप।
हेलो रीता जी, एक बार बताइए, मेरी आवाज आ रही है इस पे? क्या चीज?
दिन भर इसी की डूबी रहती है। मेरा वो अब बंद रखना। दीप्ति शास्त्री।
भेज रही हूँ मैम, भेज रही हूँ।
Good morning, sir. Good morning, sir.
Good morning. Good morning.
गुड मॉर्निंग सर।
Good morning.
गुड मॉर्निंग सर।
Good morning.
Good morning, sir.
Good morning. Good morning.
सर,
गुड मॉर्निंग सर। सुनीता तिवारी हियर।
Hi. Good morning. Good morning, speaker. Have we some students also joining the platform?
Yes sir, we have sent to all the students. The student would also be joining on YouTube as well.
Okay.
the Department of Technology students have joined in, and the nursing students have also joined in.
Oh, very good. Excellent. Excellent.
Sir, paramedical students have also joined on YouTube.
Oh,
Morning, sir.
wonderful. Wonderful. Hello.
Anita, you are the co-host now. You may admit the people who are joining.
Okay, ma'am.
Don't have two systems in one room, otherwise there will be echo.
Yes, ma'am. Just log in from one system.
ऑन करो वीडियो।
Richa, you may share the screen.
Yes, ma'am.
Richa, screen से बाकी फाइल Richa, we can't hear the video.
Yeah.
Then I need to play in that case.
Yes, ma'am. Ma'am, I was sharing it.
But we couldn't hear the video.
Okay. Okay, I'll start again.
Yes, please. Here, but we
I think you can't see that. Okay. So should I stop sharing, ma'am?
yes, reshare, stop share, and we'll start.
It's already stopped. I'll stop the audio also.
स्टार्ट वीडियो करिए अपना, तभी वीडियो आएगा।
We are still waiting for the chief guest to join in.
ये entrepreneurship एम्पावरमेंट वीक चल रहा है शायद, ये विमेन एम्पावरमेंट वीक। अच्छा, यूथ हेल्प में गई थी, रंगोली कंपटीशन था। नर्सिंग
Please all be muted. Please all be muted.
Thank you.
सबसे पहले मुझे तो मेरे किसी काम से आई थी तो मैंने कहा यम्मी है ना। मैं खा लेती हूँ, मैं थोड़ा सा रेस्ट्रिक्ट करती हूँ। हमने स्टॉप वीडियो कर दिया।
So we are still waiting for her to join. She says she's joining in 2 minutes. So
क्या करें इसको, एक वायर, ये देखो इसमें ये म्यूट भी कर दो है ना।
Deepti, you can start.
Yes, ma'am.
Yes.
A very good afternoon to all. On the behalf of entire organizing committee of InspireFEST 2020, KGMU Lucknow, I extend my warm welcome to one and all on occasion of Women Entrepreneurship Day. Women are the key player in any developed country in every field. Itself, women are the largest untapped reservoir of talent in the world. And the main objective of this online event is to share some of the success stories of self-made women and to motivate our younger generation in the field of innovations and entrepreneurship. And after that, we would like to welcome our guest with virtual flowers. With utmost happiness and respect, we extend floral welcome to our chief guest, Ms. Anju Sharma ma'am, Principal Secretary, Higher and Technical Education, Government of Gujarat. Anju Sharma, welcome ma'am. With utmost pleasure, we welcome our Honorable Vice Chancellor of King George Medical University, Lieutenant General Bipin Puri sir. Welcome sir. We welcome with great pride of Professor Uma Singh, Dean, Faculty of Medical Sciences, KGMU, Lucknow. Welcome, ma'am. After that, we welcome Professor Anil Chandra, sir, Dean, Faculty of Dental Sciences, King George Medical University, Lucknow. And we extend our floral welcome to Professor Abjeet Kaur, ma'am, Dean, Faculty of Nursing Sciences, King George Medical University, Lucknow. And we welcome to Professor Vinod Jain, sir, Dean, Faculty of Paramedical Sciences, King George Medical University, Lucknow. Now we welcome to Professor Shaili Avasthi, ma'am, Faculty in Charge, Research Cell, KGMU, Lucknow. And after that, we welcome to our speaker, Dr. Anita Gupta and Dr. Anita Agrawal. Anita. Thank you, ma'am. Welcome to all speakers and guests. Let's evoke blessings from the goddess Saraswati before we commence the proceeding of the event. Saraswati Mahabhage Vidya Kamal Lochane Vidya Rupe Vishalakshi Vidyam Dehi Namastute. After that, now I invite Professor Divya Mehrotra ma'am, Dean Quality Control, to please deliver welcome address to our delegates.
Thank you, Deepti. It's a pleasure to welcome you all to this InspireFEST, an event organized under the Deanship of Quality Control and Future Planning. And on this occasion of Women Entrepreneurship Day, it is the most apt day to organize such an event. It is to empower women to believe in themselves, as a little progress each day adds up to a big results. And the key to success is to focus on goals and not on obstacles. So friends and dear students, stop being scared of what can go wrong and start being positive about what can be right. So get ignited with this event and innovate with your out-of-box solutions to the problems faced. I'm sure this event is going to boost your confidence towards achieving your career aspirations and provide with access to national and international speakers who are women scientists that will benefit us for the rest of our career. Also, during the day, we shall listen to the success stories of a few young females and young dynamic entrepreneurs who are going to again motivate us and encourage us to proceed further in our life with best opportunities. So with these words, I welcome our chief guest, Mrs. Anju Sharma, IAS, who is Principal Secretary, Higher and Technical Education, Government of Gujarat, Gandhinagar, who has been serving in the government at senior leadership positions for more than 28 years. She is well known for her path-breaking projects like E-Mamta for mother and child tracking, Khilkilahat vans for newborn infants with mothers from maternity homes. She also has run 181 Abhayam helpline for women, School Safety Week for disaster management education, students, startups and innovation policy, and so on. So she has a huge list to her credit. I welcome our patron and our Vice Chancellor, Lieutenant General Bipin Puri, PBSM, VSM. He's on holiday, but I thank you, sir, for joining us even in your vacation time and leading us to our journey of excellence. I welcome our guest speakers, two renowned scientists from Department of Science and Technology, Dr. Anita Gupta, who is Scientist G, Head National Science and Technology Entrepreneurship Development Board from Department of Science and Technology, and Dr. Anita Agarwal, who is Technology Development Board member again in DST, that provides financial support to convert proof of concepts or technologies and to further prototypes and further validation. Other speaker for the day, Professor Monica Agarwal, who is from IIT Delhi, and she has been working on artificial intelligence. I welcome her. I also welcome our guest speakers from UK, Professor Kathy Fan, King's College London, and Professor Nazim Ghazali from Royal Blackburn Hospital, UK, who are robotic surgeons. I welcome our deans, Faculty of Medical Sciences, Professor Uma Singh ma'am, Dean, Faculty of Dental Sciences, Professor Anil Chandra, who is probably not here with us today because he is busy with the inspectors. DCI inspection is going on, so he would join us sometime during the program. I also welcome Dean, Faculty of Nursing Sciences, Professor Abjeet Kaur, and Dean, Professor of Paramedical Sciences, Professor Vinod Jain. Now, no institute can progress without research, and it is a pleasure to welcome Professor Shaili Awasthi ma'am, who is the faculty in charge of research cell and has been a pillar of research at this institution. I also welcome our young speakers, Aditi Kumar from IIT Kanpur, Dr. Ezil Rasi, who is a NEET topper, and some dynamic entrepreneurs to share their success stories. To name a few, Pooja Venkatesh from Next Big Innovation Lab, Vaishnavi Kulkarni, Intignus Biotech, Deepika from Data Science Business Development, and Ankita Gulati from Touch Vision. So these are all entrepreneurs in healthcare. I welcome our faculty members, retired teachers, alumni, and our students to this fest. And I also welcome press and media for a wide coverage of this event to raise awareness among the masses. Once again, I welcome you all to this program. Thank you.
Thank you, ma'am, for a humble welcome to all our guests and students. Now I invite our chief guest for the day, Ms. Anju Sharma, Principal Secretary, Higher and Technical Education, Government of Gujarat, Gandhinagar. We are blessed with your gracious presentation.
Sorry for the interruption. We had a
Yes, ma'am. So it's a dream privilege to have our Honorable Vice Chancellor, sir, with us, Lieutenant General Vipin Puri, sir. He's I think Deepthi is trying to connect, ma'am. Should we wait or we continue?
I think continue.
Okay. So sorry for these technical glitches we are struggling with in these COVID times. So we have with us our chief guest for the day, Ms. Anju Sharma, ma'am, Principal Secretary, Higher and Technical Education, Government of Gujarat. And we are blessed with your gracious presence, ma'am. I would request, ma'am, to please address our audience with your motivational words.
Thank you very much. Thank you all. Vice Chancellor of KG Medical University, Dr. Raval, Dr. Divya, Dr. Richa. I'm sorry, I don't know very many of you, and this is really a very unknown turf for me. Mostly I am addressing our institutions and people and gatherings in Gujarat. So it's really a pleasure talking to a group of mentors, a group of, I hope I'm audible.
Yes.
Yeah.
Yes, ma'am.
So it's indeed a pleasure talking to a group of medicos sitting in Lucknow in a very prestigious institution, talking about entrepreneurship, because somehow medicine and entrepreneurship do not, down together. And when we talk of entrepreneurship and we think of entrepreneurship, I'm sure this initiative has not been taken up by many of, or rather, not many of the medical colleges. So it's indeed a matter of great thinking, great vision that you people are thinking about it. The most important thing that comes to my mind when we are thinking of entrepreneurship in medicine, and when we talk of innovation, is that now we are moving into a world of rapid technology and very fast technology. Telemedicine is taking over now in all the realms. And with the COVID, with the advent of COVID, the necessity to go online has hastened the process of technology penetration into our houses. And because of this, we see these kind of things that we are talking online. Otherwise, you would have called me to Lucknow, and even if I would have said no, it would have been like, even if I would have said yes, it may not have been possible for me to travel at the last moment. But technology has brought all of us so close, and we are able to interact with each other so well. And in the telemedicine also that we are seeing, that even in COVID patients, I know several friends where they have taken the help of even experts from Chennai or experts from Bangalore, experts from Delhi, or even experts from places like US and UK to treat a patient over here. And that's the beauty of technology. That's the beauty of telemedicine. And that's also the strength and beauty of innovation. For innovation, we have to think disruptively. We have to think out of box. And somebody very aptly said that we have to think of doing things in a very unusual manner. And medicine is one area in which in the coming years, we see a lot of potential, lot of opportunities coming up in the area of innovation. Because of two reasons. Number one, in India, this particular sector has not yet been tapped into innovation other than pharmacology, other than medicine, the pharmacy side, and also the medical procedure side. There have been interventions, but those are very innovations, but very hardcore medical innovation. Now the world is moving towards transdisciplinary innovations. And the most important thing that comes to my mind and I see a lot of potential in the coming days, is biomedical devices. And in the entire area of biomedical devices, I see a lot of innovations taking place in the coming years. In fact, we at iHub have also entered into an MOU with the Gujarat Cancer Society Medical College and the Bioforensic Medicine of Gujarat University to have a tripartite arrangement so that we can innovate in the biomedical side and biotechnology side and in the medicine side. A very important feature of the innovations on the medicine and the biomedical side is the process of certification and accreditation. Till the time, and also the clinical trials, till the time a product, process, or a device is certified by the appropriate regulatory authority, it cannot be used. Very rightly so, because you are playing with the lives of the people, and therefore the process of certification becomes very important. The process of trial and certification becomes very important, and that's where the role of medical colleges comes very importantly. Now you see biomedical devices coming, wearable devices coming, implants coming, virtually in all the parts of body for all the medical procedures, for diagnostic purposes, for treatment purposes, and what have you. So, and also the prosthetics, we've all been knowing that. So what we need is to develop a stream of thinking, and not only thinking, but pedagogy in the medical colleges, where we can think along those lines and prepare the medical experts along those lines, where they can speak with the tech, where they can understand the language and speak with the speak on the same page with the technical experts and both of them work together to develop biomedical technology. And that's where the progress and the innovations in medicine are going to come up. The potential is huge. Huge potential we see in this area in the coming years, but we need a lot of persistent and dedicated approach to the same, because this is not something that you develop a product in 10 days, you develop an app for it and go to the market and launch it. You have to first experiment, you have to first study, you have to first try, and then you develop a prototype. And after developing a prototype, you develop a few more of them, and then you test them, and then you get them certified, and then you do a pilot, and then finally you scale it up. Very long, drawn-out process of something about at least 1 to 2 years. I know of a startup here in Gujarat. They've been working on, the startup name is We Hear. They are working on a different hearing aid technology, where they you don't need to put something in the ear, but you can put it here and you can hear it. So people who have damaged eardrums, they can very well use this technology to hear it, to hear the sounds. They have been working in this area for the last, it seems, around 3 to 4 years. And now they have come to a stage where they are on some solid footing, but still it's going to take them some time. But a lot of persistence, a lot of hard work, a lot of dedication to the whole thing that we have to do. Similarly, there are people who are working with paraplegics, the people who are working on eye problems, people who are working on inhalation devices, how the medicine can be administered better. All these kind of things. Even in the field of diagnostics, with the help of chips, you can constantly diagnose constantly monitor the various parameters in the body. So there are a number of ideas that can be tapped here. What I would suggest is, I don't know whether the university, whether KGMU has a biomedical incubator or not, that it is the right time to have a biomedical incubator. Prepare the right kind of team with the technical experts, because you would require a lot of engineering part also. So what we need is a combination of medical and engineering. And that's a field called biomedical engineering. But again, biomedical engineering doesn't deal with the mainly it's because we have all the technical colleges also under us. Biomedical engineering would deal only with the engineering aspects of it. So a combination of medicos and the biomedical engineers and the mechanical engineers coming together to work on identified projects. So what I can offer for you in this from Gujarat is that we have a system in iHub. iHub is our innovation hub for various universities and institutions. We are partnering with various industries and we are launching challenges. Provided you give us the challenges, then we can throw it open to the universities all over India, or if you want, universities only in UP, or sorry, students and innovators in UP, students and innovators in Gujarat, to provide or to think of solutions on those challenges and work with KGMU. The doctors from KGMU, we provide technical experts from here, the engineering experts from here, and the doctors from KGMU, they can work together on these ideas and can develop prototypes on that. So once the prototypes are developed, we can help in developing prototypes. And after the prototype is developed, we can tie up with the industry to take them up on a commercial basis and scale it up. Or the team itself, the innovator team itself, can take it up for scaling up or commercialization. Like the we hear people, they are doing. So these things are very much possible. And if you want our expert help, if you want our support, technical support, only if you would like to do it yourself, we would do it for you, because iHub is a government company, it's a state government owned company. I'm the chairperson of the iHub as principal secretary and also principal secretary higher and technical education. Our purpose is to spread innovation all over India. And we are working without boundaries. Very recently, we have trained people in IPR from all over the world. We're training incubators, we're training startups across the boundaries, so that boundaries don't apply to us and we can do it for you under the iHub. So we can do it if you want, and this will be, we're doing it with GCS also, Gujarat Cancer Society, and we can do it for you. So if you want, we can also have an understanding with we can have understanding with some medical college over here also, but that will be a slightly difficult process because two similar partners, they normally shouldn't. I would ideally advise that you and iHub, KGMU and iHub can have a partnership to work on these biomedical challenges. Because what is most inspiring to me, what is most heartening to note is that the initiative is coming from your side. Mostly on the biomedical innovation side, the initiative is coming from the technical side, because they see the potential. But it's like we live in our own world. So medical colleges, they live in their own world. So they don't think about these things. So that's what is the most heartening thing to note, and that's why I accepted this invitation. Also, that a team of young and very enterprising medicos, they want to talk on this topic. They want to deliberate on this topic, not because they're women entrepreneur. Okay, that's one thing. What is more important is entrepreneurship and innovation. And somebody from the medical side is wanting to talk on it, wanting to do some work on it. That's the most exciting part of it. And that's where we would like to work together. We are open to you. You can write to me. You have my email ID, you have my WhatsApp. Whatever you would like to do, we would like to extend full support to you. We would like to extend all the help to you. What we need is good teams, great teams. And I see a great team over here from the faculty side. And of course, I'm sure your Vice Chancellor is a main factor who's inspiring you into it and who's guiding you into it. But we also, and sure, you can develop a good team of student innovators also, the research, the people who are doing fellowships and people who are doing DM and MD, both, and MS, PG and DM, both. You can also get them into it, and it can happen. It can turn out into a beautiful, beautiful venture of intervention, rather, of bringing very diverse areas together and developing something very, very path-breaking in the field of medicine and in the field of biotechnology and in the field of biomedical devices. Now with Atmanirbhar Bharat coming up, since Government of India is also emphasizing on import substitution, we have a lot of potential for substituting a lot of things that we are importing right now from our homemade products. And that's where we can do reverse engineering also. We can think of various things to work on these. So it's open to you, and I am available all the time to you for a constructive project. I'm never short of time. So thank you so much for talking to you all on this platform. And I'm sure something good will come out of this in the coming days. Thank you so much.
Thank you, ma'am, for your motivational word to our audience. Now it's a deemed privilege to have Honorable VC of King George Medical University, Lieutenant General Vipin Puri sir. He is virtued by his leadership, devotion and vision as an administrator, his knowledge and skills as a clinician. We humbly request you, sir, to kindly address our audience with a word of wisdom and experience. Sir, please, sir.
Sir, you're muted.
Sir, you.
Good afternoon, ladies and gentlemen, and my dear students. Once again, a profound gratitude to our chief guest of the day. This is Anju Sharma, Principal Secretary, Higher and Technical Education, Government of Gujarat. Eminent national and international leaders who will be enlightening us with their life experiences, and my dear faculty, students of the King George Medical University. Well, as you're all aware, this Women Entrepreneurship Day, November the 19th, was founded by this American author, Miss Wendy Diamond, in 2014. And today, it has become a global movement to celebrate and support women entrepreneurs, and also to introspect on some of the challenges that they face in this movement. Over the years, the Honorable Prime Minister of India, Shri Narendra Modi ji, has emphasized that entrepreneurs need 3 C's for success: capital, courage, and conviction. I'm glad to say that the Indian landscape and the ecosystem is rapidly changing to make this conducive and implementable. A great deal is being done to mobilize a global network of female business entrepreneurs, particularly in the field of healthcare research and innovation, which our chief guest just mentioned. Earlier this year, the Women Entrepreneurship Platform was announced by Niti Aayog for providing an ecosystem for budding and existing women entrepreneurs across the country. Startup-friendly entrepreneurship is the new catchword in developing India. And it's delightful to see that 40% of these are women entrepreneurs. Healthcare and health technology-related innovation are crucial for a developing country like ours, where the skill to access gaps is huge and the demographic challenges are quite daunting. A recent NASSCOM report mentions that around 10% of the overall startups registered in this country are healthcare related. While this is it's not a very good number to start with, but I think the key factor, the critical, is going to be attractability and sustenance of these projects are going to be really the key challenge. Well, friends, with coronavirus spreading to several parts of the world and being declared a global pandemic, people are realizing the importance of hygiene and good health. Women entrepreneurs have created med tech startups like Lifeboat that help hospitals with affordable and quality medical equipment and help people be healthy and safe. On this occasion, I would like to ask the younger generation, the students, to innovate, think out of the box, develop collateral thinking, and grab opportunities of learning which come your way. From the university side, I can assure you that we will be providing every help in bringing the best guidance and opportunities at your doorsteps, and we'll try to formulate more MOUs, especially now that we had this wonderful offer from the government of Gujarat. Opportunities, MOUs, and which we'll try and bring to the university to help you for sharpening your skills of entrepreneurship. Friends, ladies and gentlemen, as they say, never give up on a dream, even if the progress is slow. I wish this program all success, and I thank you all for your attention. Thank you, and Jai. Dipti, all yours.
We're trying to find her. Yeah, she's joined. Deepti, are you here?
You take over.
I think she's not there because there was this unstable connection again. So thank you, sir, for your kind words and inspiring our audience with your words of wisdom and experience. So I now invite our Dean, Faculty of Medical Sciences, Professor Uma Singh ma'am, to address our audience.
So, good afternoon, everybody. Respected guests, our respected Vice Chancellor, and dear organizers, faculty of KGMU students. It's a great pleasure and privilege for me to be part of this Women Entrepreneurs in Health System. And when I think of talking on this, I think I immediately remember a story, and nothing more needs to be said more than knowing about that particular woman. So it goes like this, that in late 70s, there was one young dynamic lady from a typical Indian middle class background. And she was very upset and disillusioned when, even though she was good at studies, she did not get entry into a medical college. She further took zoology and tried to enter medical colleges abroad, but there the money came in the way. She decided to do studies and later on got into studying in an Australian university and specialized in microbial sciences. When she returned from there, just because she was a woman, she was not taken up by many industries and research institutions. She got really further, she was rejected so many times that she felt immensely dejected. And then she collected all her guts, she collected all the wisdom that she had. And then she thought, why don't I start myself something? And she started working on her own. She started working on something at that time, which was called as brewery, fermentation. And using that knowledge, she developed what we know as a biggest healthcare entrepreneurship. And you all know who she is. She's no other but Kiran Majumdar-Shaw, who owns Biocon. And I think there is no other living example which can give inspiration and insight that a woman, if she wants to work for healthcare, can pick up all the strings and start working for this. Nowadays, there are a lot of women, as has been mentioned, who are working in this field. And there is no doubt about it. Then women, when they decide, they can work and go on with. It's my pleasure to be part of this. If some of the young women get inspired by what is being said on this day and on the days coming ahead, it would be a great challenge for the country and for the science and healthcare world over. Thank you so much for inviting me and giving me this opportunity. It was all my pleasure to be part of it. Thank you, dear.
Thank you, ma'am. So, I think our Dean Faculty of Dental Sciences, Professor Anil Chandra sir, has not been able to make up because of DCI inspections. So I would now request our Dean Faculty of Nursing Sciences, Professor Abjeet Kaur ma'am, to address the audience.
Good afternoon, friends. Although I am an ophthalmologist, I join you representing the nursing faculty. And when I was preparing for this event, I actually went and read and came across two very important issues which were new to me. One, that a woman entrepreneur is one who, along with her own basic training, ventures into an industrial activity. And here I discovered the story of one Miss Leo George from Nigeria. This young lady, she had a mother who was a midwife and was extremely enamored by the way her mother used to make differences to people's lives just by helping them doing a delivery. And she then thought that so much of it goes into giving birth to a child, and that it is the basic family that provides the support. In her passion and lateral thinking, she sparked off an idea that why not make a group of people, or group of women, who would share the same experience as that particular woman was going through. And that's where, because of her sensitivity to her profession and the idea of motherhood, she then created a group which was called Wolomi, WOLOMI. And this basically started working with the idea that believe and listen to women. Believe and listen to women. That was the idea with which she formed this Wolomi. And then she got in touch with other support groups like the IT group, like the engineers, basically to form, who helped her form a website. A small thing in a small village in Nigeria then became a national movement in that country. This is what entrepreneurship is all about. And I feel that nurses are a group of educated women who are in a privileged position because they are a bridge between the basic society.
Ma'am, you have muted yourself.
Ma'am, you got muted.
Can you hear me now?
Yes, yes.
Hello. So they would then help to shift the focus from bedside nursing to the community and then going back into the house. That is how they would make a difference. So from the nurse's point of view, they need to recognize their passion, start thinking laterally, and start getting involved in areas outside the nursing arena so that they can be identified and picked up. And I'm sure an involvement with the nursing faculties and students in programs like this will definitely give them an impetus and help them come out with brilliant ideas. Some of them are really very innovative. I wish each of you all the best, the program a grand success, and look forward to seeing a lot of new young entrepreneur girls. Thank you.
Thank you, ma'am. I now invite our Dean, Faculty of Paramedical Sciences, Professor Vinod Jain sir, to address our audience.
Thank you so much. At the outset, I am thankful to Professor Divya Mehrotra, Professor Richa Khanna, Dr. Deepti and their team. that they have given this opportunity to me to speak about this day, that is WED. Honorable Vice Chancellor, Madam Anju, and other dignitaries on the platform, I really welcome medical sciences. Today we are talking about 4 billion unique women on this planet, and every female is unique and has got hidden talent, and we are supposed to bring out that talent, whatever they have got hidden in them, and we need to develop global network of female entrepreneurs and motivate them to be self-dependent and contribute to nation worldwide.
Hello.
See, many women from humble background, as rightly mentioned by our previous speakers, they have got the capacity and capability to run their own venture. We need to coordinate, collaborate, inspire, and help them. Two burning examples are Lijjat Papad and Akanksha, right in Lucknow. We all know that, how it is started and now how it is flourishing. This was the basic motto of starting this or observing Women Entrepreneur Day on 19th November since 2014. As rightly told by our patron, Honorable Vice Chancellor, sir, and Anju ma'am, that we have to think out of box. Whatever we are doing, we need to collaborate. Suppose we are doing in the field of nursing, paramedical, medical, dental, we need to collaborate with other persons across the discipline so that we can come out with something. And this is the day, and not this is the day, but it should be the beginning of the day that now onwards we can start thinking and doing the projects. So I sincerely thank all the organizers once again and wish them a grand success for this function. Thank you.
Thank you.
Thank you, sir, for your nice words. I now invite our faculty in charge, Research Cell, KGMU, Professor Shali Avasthi, ma'am, to please address our audience.
Thank you very much, Honorable Vice Chancellor, Anshu, Madam, other dignitaries on the dais, organizers who have given me this opportunity to speak today. When we talk about entrepreneurship, what comes to our mind immediately are big names like Azim Premji, like Tata, like Birla, like Bill Gates. But today it also brings to our mind new names from the Indian scenario, and these are women, one of whom has been named by Professor Uma Singh, Kiran Mazumdar-Shaw, but also Sugandha Agarwal, who started telemedicine, and two women very important to us, Vandana Luthra and Shehnaz Hussain, who all women require, and we are using their services. So innovation, risk-taking, financial returns, financial empires is something which we take as synonymous to innovation. But in the healthcare, there are large corporate setups like Apollo, like Medanta, etc. Again, finances, financial returns, money power. So today in this platform, I would like to say that should it only be financial returns which are a measure of success in entrepreneurship? Or should there be other measures of success of entrepreneurship? Especially when we are talking about R&D in science and technology, in medicine, success should be redefined. And today, as we discuss and deliberate, we should talk about a redefined definition of success, the magnitude of translational potential of our work, the magnitude of societal benefit that we give as a result of work. Hence, we should talk about certain attributes of an entrepreneur, which I think are important. Intrinsic motivation that makes a person work, to extrinsic facilitation, which the institution should provide, which the government of Gujarat is providing, extrinsic facilitation, an attitude of inquiry and insatiable perseverance for excellence, and most important in our medical field, an attitude of overarching altruism. Hence, there will be multiple intermediate measures of output or altruistic success in our field, right from R&D projects to publications, to innovations, to products. Hence, I feel today's virtual meeting with inspiring personalities on this meeting is most important. It should be heard and attended by many. And I would like to end with a quote that the most important thing is to try and inspire people so that they can be great in whatever they want to do, unquote. To that extent, I would congratulate the organizers. I would like to congratulate the administration of the university and other eminent speakers here. And I wish you all success. Thank you very much, Dr. Divya and Richa and Quality Control Cell of our university. Thanks.
Thank you, ma'am, for such a nice words. Now, to express our heartfelt gratitude and to preserve these memorable moments, we would like to present a small token of gratitude to our esteemed guest. I request.
She has already left.
Yes,
so
ma'am.
we can proceed with the next.
Yes, ma'am. I request Professor Divya Mehrotra, ma'am, to please present a token of gratitude to our Honorable Vice Chancellor, Lieutenant General Vipin Puri, sir.
He has also left.
Then no problem, ma'am. Then after that, moving close to the end of the program, I would like to invite Dr. Richa Khanna, Vice Dean Quality Control, KGMU, Lucknow, to deliver the vote of thanks to our audience.
Thank you, Deepti. Thanks a lot. So a very good afternoon to everyone. And I feel privileged to express my gratitude and extend this formal vote of thanks on behalf of Deanship of Quality Control Assessment, Accreditation and Future Planning, KGMU. My profound gratitude to our chief guest, Ms. Anju Sharma ma'am. We express our sincere gratitude to her for sharing her experience with us and sparing out time to be a part of this event. And I'm extremely grateful to our Honorable Vice Chancellor, sir. His constant encouragement and support has remained an inspiration behind these ventures. I heartily thank Dean, Faculty of Medical Sciences, Professor Uma Singh, ma'am, for honoring us by your presence in the event. Thank you, ma'am. I convey my gratitude to our Dean, Faculty of Dental Sciences, Professor Anil Chandra, sir. My sincere thanks to Professor Shailia Avasthi, ma'am, Faculty in Charge Research Cell, for your gracious presence in this virtual event and for your kind words, ma'am. My immense gratitude to Professor Abjeet Kaur, ma'am, Dean, Faculty of Nursing Sciences, for her support and her presence in the event. Our indebtedness to Professor Vinod Jain, sir, Dean, Faculty of Paramedical Sciences, for his responsiveness towards this initiative. Thank you, sir. I take this opportunity of extending gratitude to our eminent speakers for their thoughtfulness, which they have put in, and their tremendous cooperation, and with which they shall be enriching our participants with their expertise and experience in the upcoming sessions. I thank all the respected chairpersons and moderators who have made all the sincere efforts and will be a part of the smooth execution of the event. My gratitude to the whole team of quality managers who have worked cohesively for the success of this event. And my sincere thanks to all faculty members, student participants, alumni, retired faculty for their cooperation in participation. We also thank Administrative Office of Dean Quality Control, KGMU, and my thanks to print and electronic media for their support. So thank you one and all once again.
There's a small change in the program. As we start with the first session, she has sent, first speaker has a person in charge, Hiranmay Mohanta, who will be continuing with the lecture on behalf of Mrs. Anju Sharma. So, Hiranmay, we have made you the co-host. If you want, are you ready? So we may start with our first session.
Ma'am, may I welcome the chairperson for these sessions?
Yes, please. I'm just asking if Hiranmay Mohanta is ready, and just let me talk to him. Is he ready?
Yes, ma'am.
Okay.
Yes, okay. Please start your session.
Okay. So we will begin with the first session. Thank you, Deepti, for the wonderful introduction and inauguration. We now start with the enlightening sessions. The chairpersons for these sessions are Professor Sunita Tiwari. She is Professor and Head, Department of Physiology, King George's Medical University. And our second chairperson is Professor Anju Agarwal. She is Professor in Department of Obs and Gynae, King George's Medical University. I would request Divya ma'am to please introduce our speaker.
Yeah, because we don't have his CV, this is a last minute change. I would ask the speaker himself to introduce, because this is a just last minute change. Yeah.
Thank you. No issue, ma'am. This is a beautiful things happens in accident and serendipity. Thank you so much for having me here. How much time I will be having?
We are having almost 25 minutes for you. 25 minutes to 30 minutes for you.
Yeah, I also got to know to talk just 5 minutes before. So thank you for having me, Divyaji, Preeti ma'am, everybody. Wonderful. I assume the participants are faculty members. There are some students also?
Yes, they are on the YouTube.
Okay, wonderful. And most of them are medical science and allied sectors, right?
Yeah. Yes. Medical science, dental science, and our paramedical and nursing students.
Wonderful. Thank you so much for having me here. Anjumanam just communicated me that I should talk to the participants. Myself, Hiranmay, I act as the Chief Executive Officer of Gujarat Student Startup and Innovation Hub, iHub, which is a flagship institution of Government of Gujarat to create innovation and entrepreneurship ecosystem across 80+ universities in the state of Gujarat. So from our experiments and learnings, I would like to share certain things, and I'm sure in this span of 20-25 minutes, we can have a couple of question answer also, we can take it forward. So let me start with saying that youth of this country today is no more useless, they're actually useless. And this is something that we realized very soon when we worked with the students, creators and entrepreneurs across universities in Government of Gujarat. And under the leadership of Principal Secretary Anju Sharma Madam, we designed a policy support system called Student Startup and Innovation Policy. First time such an intervention anywhere in the country. Why we are compelled to think like this? Generally, students when they go to university and colleges, parents and everybody thinks that they will have some skills, get a good. In 2010 to 2015, we saw few students coming to us before they graduate actually to get their convocation degree, telling us that we have some dreams, we have some ideas, we have some innovations already done. Would you help us to take our innovation to market? And these are ideas which I never heard of before. So that means ये बच्चे ये कह रहे थे कि हम नौकरी लेने के लिए नहीं जाएंगे आपके पास graduation के time में नौकरी देने के लिए जाएंगे. And this was very bizarre at that time. 2010, there was no Startup India, no much of words around. But this was a very serious argument from the youth of the universities. Then we did a survey and we figured out we have more than 100 students passing out from different colleges, from different streams, right from medical, engineering, management, commerce and all, who are actually building innovations and companies. But the only thing is nobody notices them because nobody legitimizes them, nobody celebrates them. So that's how the policy came in picture. We told the graduate students that they have all the liberty to graduate by building a good product and solutions also. So therein they can graduate by building a startup also. So for example, we introduced a new program in which we told that for every team who will come with a new idea, we will give you 2 lakhs rupees in the beginning to convert your idea into a prototype. And once you show the prototype, we will give you another 30 lakhs rupees to build that prototype into a product. And if you demonstrate the product, we are going to pump in resources from the government and the money so that you become a viable business model. And our mandate is to support 1,000 such innovators and teams every year so that we can support it. You will be surprised to know, by now, we have supported more than 3,000 teams in this entire experiment. And out of 3,000 teams, 840 teams have successfully converted their idea into business model. And the average age of these young students might be 3 years old. That means there is a point to prove. If we give a platform, if we give an environment, if you give some support system, these young people can do amazing things. They can also innovate. This was the argument which we put forward before all the universities and colleges. India need to create 2 million jobs per year. Government and private sector has limitation to create jobs. Now, who will create jobs for all the graduates that we are producing across our universities? Some people need to be entrepreneurs. Some people need to innovate. And that was the philosophy behind this policy that we launched. So what we do in government of Gujarat is we fund the innovators directly. Suppose any of your student has some idea and he or she want to file a patent, we give them upfront 1 lakh rupees to file a patent. If you want to convert the idea into enterprise, we give up to 30 lakhs rupees. And by the way, these are not loans or investment. These are pure grants. We just spray and pray. We give this money to deserving teams and ensure that the ideas get germinated and these ideas also translate into business models. So these are certain things that we have been doing. Now look what has happened in the entire experiments. We have funded 220 university and colleges. We have given 14 crore rupees to the students innovators, and 2,072 of those people have converted that idea into a beautiful product. We filed 493 patents. 900 odd mentors like all of you are guiding them, and 109 institutions in the state of Gujarat are aggressively involved in this process. If you look at 2 years before, most of the brilliant students either used to go to a big corporations or a multinational or somewhere else to work for somebody else. If you look this comparison, now the best minds are not busy in solving the rich people's problem, but also the best minds of the country are also busy in solving poor people's problem. That means they are solving India's challenges, creating innovations, and also we are helping them to take this innovation to marketplaces. So in 3 years, we learned very, very hard way that if we give a platform to these young students and innovators, they can do amazing work in terms of taking the innovation ahead. So this is how the patent filing ratio has improved in Gujarat in per se. So as 2016 and 17, our students and innovators used to file around 50-55 patents a year. This year, solo it has gone up to 2020, it has gone up to 670. The single biggest vision is because we are putting incentive for the innovators, we are putting incentive for entrepreneurs, we are putting incentive for any faculty member who is coming out. So we have a policy for even faculty members who want to convert their research into enterprises. We have a policy for giving them sabbaticals so that they can go on paid leaves to convert their ideas into enterprises. And recently in the university ranking and university funding frameworks, we are also funding the universities based on their performance, how many patents they produce, how many innovations they create, how many enterprises they develop. We directly handle these innovators. So what we do is a hub and spoke model. So iHub is the hub, and all 30 plus incubators in the state of Gujarat funded by Department of Science and Technology and others are the spokes. I can see Anita madam around in this conversation. So she has single-handedly funded more than 30 incubators from Department of Science and Technology, Government of India, in the periphery of Gujarat. And all these incubators are sector specific. So if a students come from an agri innovation, we send them to the agri incubation center. If somebody comes from healthcare, we send them to healthcare incubation centers. And once they come back from the incubation and they need to grow, they need an international exposure, they need a next level funding, they need next level of handholding. That's what iHub does. So in a very horizontal ecosystem development approach, we have created this hub and spoke model of creating support system and taking it forward. Thanks to the leadership of Principal Secretary Anju Sharma Madam and Honorable Minister of Education, personally, both the bureaucracy and the political leadership of the state have championed this cause, which has gone into this level. So how do we do it? We have designed a gamut of programs. For example, we do hackathons on healthcare, design in all the dimensions. Every summer, we launch summer innovation challenge across disciplines. Every university engages their students and professors to innovate something in their domain. We fund them, by the way. We fund 2 lakh rupees to every team who come out with an idea. What we have done is we have done regional innovation centers. In the state of Gujarat, we have 4 mega cities, Baroda, Surat, Rajkot, and Ahmedabad. So rather than putting everything at one place, we are decentralizing the support system so that any innovators across the state can take a benefit. We have also created a student innovation fund. This is a 200 crore fund, which actually gives support system to any innovators and entrepreneurs across disciplines who comes to us for support. We also award them. We not only award the innovators and startups, we also award the institutions, we award the leadership, we also award the enablers in the ecosystem, because of whom the ecosystem is going to next level. Gujarat is the only state where we have a mandate to upfront financially support the entire IPR filing cost or the patent filing cost of 1,000 innovators and startups. And every year we have been able to support around 600 odd teams, but this is one area where we are increasingly focusing on. So what iHub is doing is we are setting up futuristic technology labs for startups and innovators so that at single point they can get this facility done. We're ensuring that we do strategic collaborations with different countries and different other ecosystem in the country so that our innovators and startups can network and support. So all these support systems are readily available at one place. So innovators in the state does not need to move here and there. They can come here, all legal support, financial support, marketing support, technical support, and design support. All these 5 kind of support we give at one place. Along with that, the state government of Gujarat runs these 16 flagship programs. And all these flagship programs are very much to polytechnic, undergrads, postgrad, PhDs, all kind of students, innovators, and startups. So we have a scheme called Startup Window, in which any innovator who has a product, they can access to government through a single window program. So if an innovator has designed something, he might not cut through the bureaucracy and access the government directly. But now we become a single point source. So we facilitate innovators to the central resource centers in the government. We have something called Startup Samaj. What we do in this program is we send our faculty members, innovators, and startups to different ecosystems, both inside country and outside of the country, so that they go and get hands-on exposure to understand how innovations can be further taken forward. We have a program for school children. So you will be surprised to know we have dozen startups who are run by school children. They might be 16, 17-year-old of age. So we run a program called Startup Bloom, which actually tries to harness the innovation and startup potential of school children. We also have a program called Startup Sathi. So what it does is we loop in around 200 odd existing startups who have recently succeeded in doing things, and we assign one successful startup to one potential startup in the state. We create a win-win situation, and we engage them through a period of 6 months. Every 15 days they interact and take it forward. We also have a program called Startup Manak, in which we benchmark and certify the qualities of product and startups so that they can access to business, to government, and other avenues also. We run a program called Startup Clinic. This is very interesting. What we have done is Gujarat is a very industrialized state. So we have around 50 industry clusters. And whenever a startup comes to us in every domain, we connect them to that cluster. And these mentors of those industry who work in those domains, say pharmaceutical, energy, and all, they have been assigned to these startups to mentor for a certain period of time. And that creates a very synthetic relationship and very synergetic outcome in the ecosystem. We also run a program called Startup Grow, which actually helps all the pre-incubation stage idea to go to incubation. So iHub is building a 1 lakh square feet space at the central hub of Ahmedabad to allow all these young innovators from across the state to come there, avail these facilities in a very subsidized resources, and then take their ideas to next level. And the last program recently we initiated is called Startup Mart. All the product and services that our startups produces, we have put them into a digital platform, and we help them to create market for them. So right from idea, right from mind to market, we have designed these programs to take it forward. So this is the infrastructure that we have in place. We also have house infrastructure facility for residential support system for mentors, and because we get innovators and entrepreneurs from across the state. So they can come here in the weekend, they can work around. So this is going to be a beautiful infrastructure very soon coming up. Now we have a pilot facility in the campus, and we are supporting around 100 startups in this. So one of the great things probably Gujarat has done is the entire leadership in the bureaucracy. So you can see the Chief Secretary of Government of Gujarat visits to meet the startups. The Principal Secretary, Industries, Technology, Science and Technology, Education, they comes and visit the startup. So different departments of Government of Gujarat are very seriously interacting with these innovators and entrepreneurs regularly so that their ideas can take priority shape in the government areas. So I will not take more time. This is what the program that I talked about. We send our innovators to various parts of the country to get exposure. There are school children who have designed their products, and this is very amazing. how innovators and entrepreneurs are also coming off from schools even. And this is we have been strongly working, and we've run this program very aggressively across tens of thousands of schools in the state. And this program has been very, very fabulous. We have at least a dozen startups who come from school children. So these are a few examples. I will not go in detail. These are few student startups who have recently got successful citations at the international level by Singularity Accelerator in NASA and others. And one of the interesting thing is most of the students are yet to graduate out. And that proves to our hypothesis that these young minds who are working across universities and colleges have humongous energy to prove to this country. And probably, I mean, if we can give a platform to them. For example, this is a startup which has been again supported by Anita Madam, BSS Incubation Center, supported by Gujarat government. He's cleaning rivers using the algae process. And recently he got Madam contract of 2 mega rivers here. So very innovative, a PhD in the algae reactor. He converted his research into a product, and now he has been assigned by the local river authority to clean the river. So I think this is what I was telling, that our best minds are not only engaged in solving the problems of rich, but they're also solving the problems of the country and poor. And that is one of the priority area for all of us. I won't take much time, so I thought to quickly run through the presentation. But yes, I will be happy to take few questions if any of you have. Thank you.
That was really very interesting and inspiring. I will ask Professor Sunita Tiwari, the chairperson, to sum up your entire talk, and then we'll take questions from the students. Students can give me questions in the chat box. I'll note them and ask them. Sunita ma'am or Anju ma'am?
Yeah, thank you, Mr. Hiranmay. It was a wonderful talk and very thought-provoking. We definitely have a lot of potential in our students, and giving them the proper environment and the proper stimulus, as you have done in Gujarat, is very important, which needs to be copied across the whole country. And the number of patents filed by these students is really impressive. And the iHub which you described, it is something which really is good and is going to take our country a long way in combating unemployment, in helping India to reach its dream of being one of the leading countries of the world. And such programs really need to be duplicated all around. So thank you very much for such a thought-provoking talk. And I invite any questions from the audience.
Yes, Dr. Mr. Mohanta, it's really very impressive showcasing of what you in Gujarat have been doing, and it would be very heart welcoming to have collaboration with KGMU so that our students, which are the brightest minds, and they get the facility to bring up what is in their minds and develop it into a prototype or a concept which can be further driven with your support to a full accomplished. So thank you very much for updating us what is going on in the Gujarat section. I think it is a tremendous job which you people are doing. And if we can have something like a small miniature of iHub at KGMU, it would be very welcoming. Would need to discuss more about it and see how we need to further take it up.
आप सबको शेयर करेंगे. In fact, I can see Anita Madam is there from DSP. All this is happening because we have mentors like them, and they have been putting it from the top. So Anju Madam, Anita Madam, so they are champions, they are veterans. But what we are doing is just to liberate their blessings and ensure that we do a contemporary approach, because today's youth is very different than youth of a couple of decades before. And that's what we are liberating. And one point that I would like to share here, out of all success stories, 80% of them come not from Ahmedabad, or the capital part of the city. They come from different districts, even taluka level. That has ensured us one fact that there is much hunger to be tapped from the remotest part of the state and country. And we are struggling really how to go to these people, how to find out them. But once we do that, I think our outcome will be magnified tenfold.
I think to start with, if we could start with some training of the students in this field, if we could initiate that, it would be very good.
Absolutely. In fact, what we did recently is Principal Secretary took a leadership and Gujarat government made a mandatory for every university to have minimum 4 credit on innovation and entrepreneurship and not theoretical prospect, hands-on. So what we do is, if an MBA student or engineering student want to graduate by building a product, we allow them. And this is how AICT also has given us that flexibility. So either you go and write examination and get the graduation, or you build a product and still you graduate. So both kind of flexibility that we have accommodated so that somebody can learn well in examination and somebody can win in the life examination also.
Yeah,
so
because in engineering colleges it is happening, but I don't see this happening in medical colleges. So this is what we want to have at our university.
I'm happy to know that
one should be very fruitful if we have it in medical colleges.
Products which we have supported by Gujarat government comes from medical devices, process and pharma domain. So we have a very significant bunch coming out from the medical domain. Probably one of the region, Gujarat is a pharma hub, and we see a lot of these innovators coming from healthcare, particularly the MBBS and other people working in diagnostic in other areas. So though it's a longer gestation period, your domain is one domain where you need to work 5-6 years to build a trust. But then we see a significant amount. I think hunger is equal. We just need to create a support system a little differently.
I would like to ask you one thing. Will having some competitions or having some challenges for the students, like we bring out one innovative week where we enhance our students and ask them to come up with that idea, can help us with this whole idea? Or have you done this and found some results?
Yeah, we run a program called Open Innovation Challenge. The program's name is Mind to Market. We run it across sectors. We give 6 months time for every team to come with a proof of concept. We fund them. We have some understanding, some insights. I'll be happy to share that. But students have been amazing. If one stakeholder in the entire system who has never disappointed us, that is students. I mean, we might have disappointment.
And one thing more I want to ask, like, how do you take care of the conflict of interest, the conflict of finances which occur once entrepreneur has formed and it has been sanctioned? Because what happens in a team, that the idea is shared, but once it becomes successful, people try to take the entire credit. So how do you take care of this whole concept of conflict of interest once the idea is approved from your side?
First of all, if it is IP-based product, we do a non-disclosure agreement. That's one. Second, all the money that government gives is grant, but we help them to get private capital or into investment and others. We help them to curate their term sheets of investment so that they are not exploited by mature ecosystem stakeholders. Number 3, we also, in this program, as I mentioned, we have a program called Startup Clinic. Any innovator in the state can come on our website and book a slot. We give them technical, legal, and other support system free of cost, in which our expertise in-house will help them to create term sheets and also the founders agreement documents, so that the conflict part of the innovation or the startup when they grow up is mitigated right from the beginning. And we also have mentors, as I mentioned you, the startup Sathi. So we give them mentors who actually mentors them every month. And we track these mentor-mentee engagement through an online platform, and kind of jury we facilitate if any dispute. So we try to ensure that we play a big brother's role in the family and help them amicably take this thing forward, both for strategic purpose and both for interbehavioral issues.
Thank you so much. This is actually very important. I would request Professor Sunita Tiwari, ma'am, if she has some comments. Ma'am? Divya ma'am, I believe, thank you, Mehenta ji, and I hope we come to the end of the session.
Thank you so much, ma'am, for having me here.
Divya ma'am, we have one felicitation certificate for you. Thank you, Mr. Hiranmay Mehta, for your talk and for patiently answering our questions. And I hope, as Divya ma'am said, we can have some link with your iHub so that we can also have some good efforts of our students brought to market or actually making some difference to the Indian scenario. Thank you so much. Now I would give over to Divya ma'am.
Anything.
So I would like to felicitate our chairpersons also. We would, Dr. Preeti, can you do the needful?
I would like to felicitate Professor Sunita Tiwari. She is Professor in Head Department of Physiology, and Professor Anju Agarwal, Professor Department of Obstetrics and Gynecology, King George's Medical University. Thank you, ma'am, for your presence and your support. And thank you all the listeners. Thank you.
Yeah, and thank you so much, Preeti, for moderating this session so nicely. Thank you so much. Thank you. We thank the chairpersons and thank you, Mr. Hiranmay. That was a indeed beautiful talk. Thank you.
Thank you, sir. Thank you, ma'am.
29 rupees. Don't worry, मैंने अपना number दे दिया है. उसको बोलना मुझे.
The second moderator can take in now. Rhythm, are you there? Otherwise, Richa, you please continue.
Yes, yes.
With the session.
So our second session, the chairperson, I would like to invite our chairpersons, Professor Abjeet Kaur ma'am, who is currently Dean Faculty of Nursing, KGMU, and also Head of the Department of Ophthalmology, KGMU. And I invite our chairperson of this session, Professor Amita Pandey ma'am, who is Professor, Department of Obstetrics and Gynecology, KGMU. We welcome you both, ma'am. And I would request you to please introduce our speaker for this session, Dr. Anita Gupta. Ma'am, you are muted, ma'am. Abjeet ma'am, you are muted.
I have been given the proud privilege of introducing Dr. Anita Gupta. And I must say that up until now, I have very easily been able to read out people's CVs for their introduction, but this one seems to be running into pages. So I will have to read it out. And Dr. Gupta is a doctorate in engineering from IIT Delhi by qualification and an administrator by profession, with over 20 years of experience in managing the Government of India-led programs on innovation and entrepreneurship. She is currently head of the Innovation and Entrepreneurship in the Department of Science and Technology. She has played a pioneering role in steering horizontal and vertical growth of innovation entrepreneurship and the startups in the country. She has been a lead catalyst in establishing over 100 technology business incubators at institutions of academic excellence, including IITs, IIMs, NITs, and leading private universities. She has also been instrumental in carving out a new umbrella initiative called NIDHI, National Initiative of Developing and Harnessing Innovations, under the Prime Minister's National Initiative of Startup India. She is deeply involved in transforming the Indian innovation landscape by engaging new models of public-private partnership with leading MNCs like Intel, Lockheed Martin, Boeing, Texas Instruments, Tata, Bennett & Coleman, etc. She is driving the key program on innovations, that is India Innovation Growth Program, Power of Ideas, and Innovate for Digital India. At the national level, she possesses enriching experience in promoting not only the startups based on technologies of excellence, but also in empowerment of the society through nurturing micro-enterprises based on technologies of relevance. In the ministry, she heads the new and inclusive component women entrepreneurs technology. I'm sorry for the disturbance. And few of her recent work are first of its kind initiatives in the country, which includes setting up of departments, first research park in IIT Gandhinagar, seed and acceleration support for startups in incubators, India Innovative Challenge for engineering students, plug-in, a first hardware product-based incubation program, and lead a unique bilateral program, Indo-Russia Bridge Program for Innovations. Apart from national outreach, she has contributed immensely in fostering result-oriented international linkages with countries like China, Malaysia, Cambodia, South Korea, UK, USA, Switzerland, Russia, Israel, Australia, Sweden, African countries like Rwanda, etc. Recently, she has also led few delegations of startups to USA and Russia. She has contributed a number of articles in leading forums and platforms, including print and digital media. She is regularly invited as speaker, panelists, and resource person in numerous events and conferences, both nationally and internationally. I must put on record, Dr. Anita Gupta, my immense appreciation for the amount of work and sheer grit that you carry by virtue of being an engineer and an innovator. I invite you to this session to give your talk.
Thank you so much, Professor Abhijit Kaur, Professor Divya Malhotra, and all those from this King George Medical College. It has been a pleasure for me to be a part of sharing my insights, my journey, working with innovators, entrepreneurs across the country, and how the landscape has really evolved of 2 decades of my association in this capacity, working with Department of Science and Technology. So I'll be sharing those insights, but let me start on a bit on a lighter note that we are celebrating Women Entrepreneurs Day today. But today I'm told, I just saw the WhatsApp, it's a International Men's Day. So what a beautiful coincidence that we are having this event today. So let me begin formally with, I'll just quickly walk you through what has been the journey of the board which I am currently heading, which is known as National Science and Technology Entrepreneurship Development Board. This board started its journey of fostering innovation, not innovation at that point in time, that was mid-80s. We had focused on how to convert and translate job seekers to job generators. And that was our primary intent when we started off all our activities, and through a lot of training activities were given. And our target zone was primarily institutions of excellence in engineering domain. So that was our target. But unfortunately, we have never touched upon medical colleges or institutes. But we thought that on 2 fronts, medical professionals are like they resort to entrepreneurship by their own, because you see they are having hospitals, they are having their own clinics, whether it's in the various domain or be on the dental side. So entrepreneurship is an integrated, you can say, element, but there's no formal kind of, you can say, initiatives or activities which are proactively being actually thrown upon to students and faculty. It happens naturally. It is triggered naturally, and this is happening. But as we walk through, I have many slides to share. As we move on, I'll just share about what the interventions we had. Very handful one with the medical institutions and medical professionals to say with, but it has attained a lot of relevance as we go along, particularly when we are witnessing pandemic like COVID-19. Where it is so very important to have a strong partnership and have a team of multidisciplinary skill set. So particularly when we are developing the healthcare related solutions and also focusing on assistive technologies, which is a key focus area of late in many of our programs when we target both healthcare as well as socially relevant solutions. So I'll be sharing my screen.
Are you able to do, or should I share my screen to present your?
Yeah, give me a few seconds, Divya. Okay. Is it now visible?
Not yet. You have to click on the green. Yes. Yes.
Is it there?
We can see it. Yes, it
Yeah.
is there.
So I'll make it full screen. Problem in getting full screen.
You should be able to.
No, I think it's okay now.
Yes, it's fine.
So yeah, so thank you. I formally will share through the slides which I have prepared to give you a glimpse of what we have been doing so far within the Ministry of Science and Technology. More so, department, as Hiranma has already shared, department happens to be a pioneer as far as the innovation entrepreneurship goes in the country. And we have been doing it since mid of 80s, as I've shared with you. So the whole slides have been prepared in a way just to walk you through who we are, what we do, what's entrepreneurs, what's incubation all about, the Nidhi program, which was conceived as shared when my CV was being read out. And what do we do? How do we really scout for innovations across the country? What are the mechanisms? What are the support levels which we offer? We'll share about some success and failures too, because that's so very important to learn, and the kind of impact which has been created, and what do we do as a future blueprint for us. So this all will be shared in my slides. There's a quick snapshot. I think most of you are aware that we are the one department within the Government of India's various departments who are steering science, technology, and innovation. Earlier, we used to focus on only science and technology. Innovation has been an added part as a clear STI. We don't call it now. Ideally, it should be DSTI, not the DST, because innovation has become a central piece of all of our activities. What earlier we were doing as a part of Government of India, whatever proposals are coming, we were really receptive. But there's a role reversal now. We are more participating, more proactive in reaching out to the larger set of people, citizens, and societal participation, institutional participation is more on the proactive side. And that's how we are contributing significantly in the growth story of the country. We are actually, within the department, we are responsible to chart out new policies to science, technology, innovation, R&D. How do we really, we are the primary body in funding the extramural research in the country. And ICMR is the analogous one as far as the healthcare goes. They fund a lot of healthcare related, but we are sector agnostic. We cover entire domains of science and technology and innovation, and where the three pillars which we focus on: creating the human capacities, creating the infrastructural facilities, which should be the state of art to carry out the requisite quality of R&D work, and also enhance the institutional capacity through a variety of funding programs and schemes we have. And we have close to 20 divisions within the department, which are assigned role for different activities. My board is only comes at the later stage, like from lab to market. Whatever has been done through R&D, how do you really figure out what kind of solutions are there which are viable for commercialization, which could be taken up in the form of good products or improvement in services through the route of entrepreneurship and incubation. So that's what we do within the our vertical does. And of late, in last 3-4 years, there's a lot of focus on bringing the you can say the high level of technology which is being steered by a lot of developed countries. So we are focusing on quantum technologies and its application, which will change the face of across all of, be it medical, be it like agri. So which will be having bearing in all the domains, as you know, the way internet has penetrated, and it is actually really helping all these strata of the society, all the domains of businesses, all the domains of the way education is being now delivered. So technology has become backbone of all the kind of work we do, how we really live as a society, how do we really improve our performance and tackle various challenges. So for variety ways, technology interventions have a lot of relevance as we go along, as we move forward. And a lot of activities are there. How once we scout for innovation, how do we really give a demonstration? How do you really engage with international on a bilateral and multilateral level? Because there are certain products, there are certain activities where the startups may be having a market in different, like many of our societal related products will find a place in the African market, developing market, be it in the healthcare side, agri side, energy side. So there's a strong focus on, we are having currently more than 45 countries, with 45 countries, this kind of international cooperation from researcher to researcher level, from and few are having from the startup or entrepreneurship level as well. And how do you really translate the benefits of the R&D to society? And that's why we have a seed division for societal empowerment. We have a lot of activities where we are really changing how we can bring a sea change in the quality of life of people, because there is a lot of urban-rural divide in the country, and the kind of facilities and the amenities we enjoy at you can say at metro, at the urban level, or rural India is devoid of. And how do you really try to balance it out? That's how Innovate for Digital India was the program which we supported. And we have more than 18-20 autonomous institutions. And I must say that we are the only one entity department in the government of India, other than Ministry of Health Research. We have one body, autonomous body, Shri Chitra Institute of Medical Sciences and Technology, based out of Trivandrum, which is the postgraduate medical institute. And I think if anyone is in the cardiology, they must have heard of the Chitra Wall, and that was their name to fame way back a few decades back. So Shri Chitra did a lot of work in the COVID-19 area, and I think they've come out with some very good, remarkable products across, be it like low-cost ventilator to different sort of diagnostic devices. I'll be sharing few of them. And we have 3 international bilateral centers as a part of DST. With one is Indo-US, second is Indo-German, and third is Indo-French. This is a glimpse of as a collectively what in DST we are doing. as a part of policy which gives a blueprint of how science and technology will take shape for the country. We are currently charting out a new science and technology policy 2020. A lot of stakeholder discussions have gone in place. There's a key element of really engaging with the institutions which have been left out, like medical ones.
Yeah, just now I saw the mail. There's a woman.
Also, we are actually focusing on how to build a nation which targets faster, sustainable, and inclusive growth. Let me now come to my board. This was set up in '82. As I shared with you, the key intent at that point of time was how to really convert job seekers to job generators. But of late, as per the market dynamics, we have added more layers of our mission. That is now since when India gained prominence in terms of IT services, we have really changed it to how to convert knowledge to wealth creation. Now we are also creating another layer, how a young population, young talent pool could be problem solvers of variety of problems. India as a 1.37 billion people face with a lot of different geography, diversity in culture, language, in terms of developments. So how do we really target our own problems to be solved by our own people who are so talented? So that's a new thing. And the fourth pillar now which we have added is to be self-reliant or Atmanirbhar. So that's how we, the while core is to convert job seekers to job generators. On the periphery, we have added, we are actually adding more layers as per the market demands, as per the nation demands, as per the call for New India is there. So innovation, what do you really call as an innovation? A new idea, creative thoughts, or which could be in the form of a device, method. It's ultimately result into application. So we are not interested. You got a patent, one got a patent, but if it is not monetized, if it is not put into use, it's of no use. So we have to really translation of innovation to marketplace becomes a key domain to work with, and that's what we are focusing on. How do you really take forward viable solutions to market? That is to the root of entrepreneurship. And the platform which we use to foster entrepreneurship and startup ecosystem is the incubation route. That's also entrepreneurship is actually a French term, and you have to really generate wealth, employment, and social good. That's the ultimate aim of entrepreneurship. And as we really analyze the Indian features, why India as such, society is risk averse, but we have been entrepreneur. If you see like even Panwala shop or any small vendor, they are a variant of entrepreneurs. So they classify one who is earning their own bread and butter without depending on any other. They are the first element of being an entrepreneurial society. And we have some positives, like we have a vibrant capital market, strong technology base. India is supposed to be, in terms of demographic dividend, we are the ones close to 60% of population is in the working age population. And how do we really leverage this this demographic dividend to the benefit of our country, solving variety of problems or for the socio-economic growth of the country? That is the focus area for us. And we have seen we have sizable market of customers. There are so many unmet needs, starting from healthcare to education to energy to transportation, you name. And we have you can really translate those challenges into new opportunities. That's how the innovation, that's the first germination, how innovation takes place. One has to be really observant. Where does the problem lie? Where does the unmet need? Where is the pain point? And what sector, how it really could be addressed through a solution. And that's how the innovative team or innovators start working and stitching together various pieces which are able to solve the unmet needs. And then comes the issue of really it is it can be commercialized. If so, how? Does it make a business case? If it is making a business case, what is the next step? How to really, and if it's a very new innovation, how it needs to be protected through patents. How do you really now then the other steps follow after that, and once you have really given a call that it needs a business case, there we come in the form of variety of programs and the platforms which we have created. So this is I have already shared, so I'm just skipping off. So what we have created a mechanism. DRDS has been a pioneer in propelling the concept of technology business incubator in the various hosted by various academic institutions, where we are actually creating one you can say one platform where any innovator an entrepreneur startup could walk through, and they are provided all sort of support, be it in the form of mentorship, be it in the form of some funding, so that within a medical fraternity can so very relate to what is incubation all about. So when the conducive conditions to survive and grow on their own are not there, you create those kind of conditions. So as premature babies in an incubator, the kind of conditions which are required, the right kind of temperature, or so those conditions we are trying to replicate for any fledgling startup or innovator, that they are first generation entrepreneurs. They don't have prior backing, they don't have any prior knowledge how to really go about. They come with only idea that needs to be protected, that needs to be really worked upon, that needs to be validated. So how do we facilitate all this? That is under the roof of incubator, and many faculty are also engaged in providing all technical mentorship. Business mentorship is arranged through a panel of resource people who could be in that particular domain. How do you really, once you have validated the product, you need funds to scale it up. While initial funds could be provided by our schemes, but that is not sufficient enough. You need to really see the market players come into play, investors come, market investors are there, angel or venture capitalists. They are there, they believe in your idea, they see confidence that it can make a market success. And during the incubation period, through variety of programs, these products are really curated to that level that generates enough confidence from the investor side. And that's how not all, but many land up in getting good traction from market and from the investors as well. So this is a schematic diagram of how really each word signifies what an academic campus, this incubator, should do. So obviously based on the rigor of academic rigor, research rigor of the institute, and depends on how the ecosystem is flourishing within that institute. So these are the sort of different pieces to make it a big picture of, you can say, a visible picture. It's backed by good, decent government support, primarily by us. And now I must say many players have joined our hands. While we were pioneers, now you see AIM, Atal Innovation Mission of Niti Aayog, even Department of Defense Production, Ministry of IT, Ministry of MSME, even ICMR, and all have joined hands, MHRD. So now Ministry of Education, it's renamed as. So they have all come in big way to steer the entrepreneurship agenda of the country, aligning with the now National Initiative of Startup India. And I must say now, as I speak now, I think more than 26 state governments have also proactively in last 3-4 years have actually announced their startup policy. As Hiran has shared, Gujarat happens to be consistent topper in the state ranking, while UP in the latest 2020 ranking announced by DPIIT, Department of Industrial Policy and Internal Trade, which is the nodal body for Startup India, has positioned UP as the emerging startup ecosystem, and UP, I must also needs credit because they have announced a very ambitious policy and targets of setting up 100 incubators, and one district, one product is their motto for driving entrepreneurship in the state itself. It's a very welcome move and initiative, and this needs to be harnessed at fullest potential to really embark on the entrepreneurship journey by the state. So this was in 2015, August 2015, when PM announced that from Red Fort that Hindustan में कोई ऐसा जिला ना हो, ऐसा block ना हो जहाँ कोई startup ना शुरू हो, and that's how he coined and the initiative Startup India, Stand Up India. So Stand Up India primarily is to actually for the marginalized groups, for the sections we have which have not been represented well in these startups, and women constitute a big part of it. So to align with our programs with Startup India, we figured out like what are the missing pieces in the innovation to market value chain, and quickly came with some of the programs. One was idea to prototype. There was no Prayas program promoting young and aspiring innovators and startups. It was coined because once you have an idea, there's no funding coming way. You don't have a startup registered as of now. Who gives you fund to translate that fund into working prototypes? So there's a Prayas. Some of the students, are struggling, have the zeal or passion for having a startup, but they don't. There is some initial reluctance or some societal. Even parents sometimes are not really forthcoming to encourage and motivate their sons and daughters for entrepreneurship career. So we came out with a entrepreneurship in residence EIR fellowship. It's a modest one, 30,000 per month we give. And after the end of the program, they have to come out with a good idea through which startup could be registered. And I must say these are the pre-incubation level programs. And during the Kumbh, Prayagraj Kumbh in 2019, one of the classroom project from MIT Pune, those students figured out an idea because elderly people used to feel while using Indian toilet because of knee issues. The students saw that their dada was facing a lot of problem, and he figured out a new design, which is a retrofitted one, and the product is Squat Ease. It is available in Amazon, and this was deployed in the Kumbh Mela. I think 5,000 products were there. So that's how classroom journey landed up, and they were actually recognized. Today happens to be World Toilet Day also. They were also recognized and awarded by PM and World Toilet Association for their innovative design of Indian toilets, which enables elderly to use this Indian toilets with much ease and not much of hassles. So we have to really, now my message will be only whether you are engineering, whether you are medical, whether you are in agri area, whatever area, or whether you are a simple housewife or whatever capacity, you have to be really observant to be a key player and making a mark in the society. We cannot sit as it is. We have to be really observant and figure out what are if we target only our immediate areas, whether it's a home or even your society, residential complex, we can come out with so many problem statements. There are so many problems, and collectively, if we try to solve those problems, I think, and this becomes a mission mode, I think India will be a very different place. We are struggling in so many issues. We say we have 1.37 billion of people, but million of problems. So who is going to solve? It's only we can solve, and that kind of mission, that kind of fire in the belly has to be there. That we have to be really observant. We have to really see what kind of problems are there, how we could solve collectively. We have to leverage the power of collaboration, because we may not be having all wherewithal, We have to see and reach out who could be our partners in the game or partners in the crime, whatever you may call. So you have to really be observant. This I can skip because this talks about the kind of funding program. We give 10 crores to 15 crores to set up the basic model for incubation. It has to be registered as separate not-for-profit legal entity, section 8 we call. We also parallelly supplement this program, incubation program, with a lot of capacity building, training of incubation managers, India and abroad. And like EIR, we give funding over, and these are all over and above what we give for core incubation support, Prayas, Fab Lab, prototyping support, seed support, acceleration support. And we also partner our top performing incubators where industry comes and joins hands with us. And then state governments also sometimes proactively supports whatever initiatives which we have supported on equal and matching through equal and matching grant, and international bodies also chip in wherever required. So this I've already shared. Prayas we give up to 10 lakhs. We call it Prayas Shala, wherever these kind of centers are there. And so far we have supported in both the cases about 400 innovators, and 78 about 78% have really translated into a real startups. So, and I think 135 patents have been filed in Prayas grant and 78 in the EIR program. This also skip is not. These are the logos of our leading incubators. Venture Center, which you see is a Pune, is a leading one in the biotech and healthcare domain. But most of the e-health TBI in Bangalore. We have 2 incubators. As I told you, Shri Chitra is in the medical devices sector, and so is the case with Narayana Hridayalaya also. So and even Manipal. So these are the ones which proactively focus on the healthcare, health tech and medical devices and even assistive technology domain. And most of the IITs have a complementary skill set. Many are in the healthcare domain and medtech domain. This is India Innovation Growth Program, which has this is the longest running program in terms of it has run into decade. We have completed the second version also with Tata Trust and Lockheed Martin, targeting both university chair and open innovation. And healthcare takes prominence in all the if you analyze year wise, I think 30% are in this innovations come from this domain. So is the case with the power of ideas, which we ran with the Economic Times. It is run once in 2 years. So it is also touted to be the biggest idea scouting platform, where 18,000 plus ideas are actually we are able to assemble in one call. This is for engineering students with Texas Instruments. And if you see, like many of our incubator startups or entrepreneurs have really made into the cover stories of whether it's a business world, Robosoft Technologies, or first is the Krantikar, but we don't see women making headlines. So let me just dwell a bit on the one entrepreneurship piece. See, Lijjat Papad has been shared. So 3 P's were pickle, powder, and papad. These were the women are because their large work zone was confined to kitchen. So obvious they have come out with innovations and entrepreneurs which are tailored and oriented around their the domain and the skill set which they have exhibited. But we see many now in the 3Hs: health, hygiene, horticulture. Now you name 7 E's: energy, environment, education, entertainment, electronics, and engineering. Now there's no area which is led where women have not really made their presence felt. We have so many startups in aerospace domain, biotech. Okay, role model is Kiran Majumdar, but there are so many women in the biotech who are DBT is represented by more than 60%. They are all women officers, and it's obvious. Even in medical, I don't know what is the latest percentage. They could be close to 40-50%. The intake level. So women are close because of obvious reasons. They are well represented. But aerospace, there's a cutting the glass ceiling. fintech, gaming and entertainment, smart city, textile, transport. I was a jury of the National Startup Award by Ministry of Skill Development Entrepreneurship last year. And when we top two in the supply chain and transport for women, which is unheard of. So women are actually breaking the glass ceiling everywhere. And it's only they need the conducive environment, support system to develop that kind of confidence. They don't lack anything. It's only the societal thing which is sometimes prohibitive and restrictive for their participation. If you say last bullet, in India, almost 48% women drop out of workforce before they reach the middle of their careers, compared to the Asia where it is 29. So India, women study, but like they are not part of the workforce, which leads to the economic development of the country. And what we have to really map them and analyze what are the factors which really there's a leaky pipeline in spite of having talented women in our society. And that's how way back, I think India started, our DST started with a Kiran program, particularly women in science, let them give an opportunity to join the workforce or be part of the research career, even if there's a break in career. So the Kiran program is doing a lot of activities. And there was a Dell, which is Dell is a computer company based out of US, and they showed that India has a lot of promise as far as a woman being an entrepreneur. But this was 2012. As we see 2020, how the woman entrepreneurship has really shown the progression is like in 2010 it was 8% in terms of representation of women in the startups. It rose to 14% somewhere in 2016. As we speak now, it's 20%. So it is gradually rising, and that's a good indication. So what does the women being of the feminine perspective of being in the entrepreneurship domain, which is primarily driven by STI, science, technology, innovation? Because if you see e-commerce, healthcare, consumer durables, when there are some progressive companies, they design the products assuming what will be the feedback of women as a consumer, or so their feedback, their needs and requirements are all taken into perspective. And that's how when they hit the market, the women are a part of their core team. Healthcare services, like there are so many. Saral Health, I'll share about Suhani Mohan. Suhani Mohan is a IIT Bombay alumna. She actually focuses a lot on the women's menstrual hygiene. She has created, because of engineering skill set, automatic sanitary pad making machine, and it has been awarded through various forums through our programs as well. She was part of my delegation to US in 2017. Now she also tweaked her, you can say, engineering skill set through COVID situation, and created an automatic 3-ply mask making machine. And this is in partnership with Mahindra's as well. And we have funded her in one of our program, which I'll just share. There are many I don't know whether anyone of us heard about Sugar Cosmetics. So Sugar Cosmetics, driven by Vinita Singh. She is an IIT Madras, and I am Ahmedabad alumnum. She left her 1 CR job and ventured into entrepreneurship because she had that passion that she wants to be her own boss. And now India is the only country where to promote leadership, women, it is mandatory for women to be represented on board of directors. So that's how we will bring diversity and inclusion in the whole working of our businesses. What we have really done in within the DST, we have certain women universities. We have proactively given the incubation in Delhi. It's Indira Gandhi Technology University, Periyar University in Trichy, then Padmavati Vishwavidyalaya in Andhra, Women Entrepreneurship Quest is we support this program to scout for women startups in technology domain, and as a part of this award, we take delegation of top 10 women startups to US, and I've been driving this initiative ever since it was conceived. And over the years, I have seen the quality of women founders and innovators, a very drastic change in not only in the kind of passion, the confidence, their commitment, and their full knowledge of the domain they are working. They are so confident to talk with investors and showcase and pitch before anyone. And that is really, you can say, heartening to know that women, given the right set of education, knowledge, and support system, they can really do wonders even in the entrepreneurship journey, which is considered to be really challenging. We are empower, and we have supported many accelerator programs also. And as a part of this program, Government of Canada takes a top 3 for an all-paid visit, where startups can really study the law of the land, and if they want to set up their businesses in Canada, they are most welcome. Canada is the most welcoming country for anyone, be it for education or even for a working professional, or be it entrepreneurs. We Entrepreneurship program, we support with IITs, IIT Delhi, IIT Bombay, and IIM Bangalore. We have supported along with Goldman Sachs Women Startup Program in a hub and spoke model. And there we take it top ones to Israel also to visit. Israel is also very supportive for women startups. So, and many companies like GE Healthcare, Cisco, Intel Capital, IBM, they're all working to work closely with women. I think many of the e-commerce company like Walmart and all, they have a policy where 30% of procurement has to be done by women-led startups. The products have been. So India, and as per the this McKinsey study, Institute study, if we really provide a level playing field and engage our women force in all our economic activities, we can really grow our GDP. I think 1.4 percentage points. That was the outcome of that study. So it's a lot of potential. As Sheryl Sandberg, CEO of the Facebook, has already said that we need to bring equality and gender participation or gender mainstreaming, not only in governments, our business, our companies, our universities. That is, if we really change that trend and bring that mindset, I think whether it's entrepreneurship or whether it's any area, women can really, I think our defense forces have opened to our women also in combat position. These are all positive pieces to be stitched together, that we need women at all levels to change and reshape our conversation. And women could be a really game changer for the new resurgent India, which we speak of. These are, I've just shared about our focus on biomedical engineering design. We have one at IIT Bombay, which is purely on the assistive devices. With I think Tata Memorial Center is also equally involved in that. The state government, central government, hospitals, we need a big complementary skill team when we target the healthcare related innovations and startups and entrepreneurship. Another one I've shared also, talked about Sri Chitra. We have a exclusive business incubator on medical device. This is the program which I coined way back in fag end of March when pandemic hit us. And we had to quickly reach out to 150 odd incubators and across innovators, not only our incubators, but reach out to the innovators across India, startups across India. Where are the solutions for handling the 5 verticals of this pandemic? One was of course ventilators and respiratory devices. Second was disinfectant and sanitizer. Third was PPEs, protective gears. Fourth was repurposed drugs and all, and fifth was the informatics or IT-based solutions like we have Arogya Setu app, and we targeted 50 lakhs to 2 CR for those kind of startups. And We completed this process in a record time. We announced top 51 solutions. And as we speak now, India has really shown the power of collaboration, power of innovation, power of startups and entrepreneurship when there's a clear sense of purpose and there's a criticality of time. When in March, we had no indigenous diagnostic kits, we had no indigenous PPs, now these and no indigenous high quality ICU grade ventilators. Now we have all. And few of them are getting exported also. So from zero to surplus, we have attained in a record time only by the sheer power of collaboration and all working in closely in tandem with each other. So once we can do, I think wherever required, this is COVID has been an eye opener for us, game changer for us for as far as the Indian innovation goes. And we have many examples to share in this regard. Noka Robotics is the IIT Kanpur alumni supported very high-end ventilators, which is being deployed, I think, in various hospitals. These products are all designed by women, and they have made a very really market success. I talked about the Saral design. This is a automatic machine for 3-ply mask generation. This is a cradle-wise smart sensor based cradle designed by Indian Institute of Science husband and wife couple team. They worked in Texas Instruments, lot of industrial knowledge they had. And when she had a baby, and it was problem to really keep, the parents were awake throughout the night, a baby is crying, and they had this which works at providing the conducive environment and even provides you automatic swings when baby cries and monitors. So there's a baby monitor as well. This is an engineering design product, but purely came out of the need felt by the woman entrepreneur Radhika. And we see a lot of artificial intelligence and AI ML taking roots in the even healthcare domain for even enhancing the patient outcomes, even for the diagnostic piece. And in COVID, we have supported more than 30 products only on which are AI led. And I think many we collaborated with many hospitals like Medanta and all, because whatever solutions are there, it needs to be developed in collaboration with clinicians, with the doctors. Most of the ventilators were developed with pulmonologists on board right from the day one. Once you conceive the product and go back to the drawing board, you need to have the real people who will approve your product, who will come out with the, okay, what works, what may not work. So while designing a team for such kind of products, you have to have a right mix, clinician, doctors, product designers, engineers, and then it has to be tied up with the manufacturing, like who will do the manufacturing piece. So these are the various elements how innovation really sees the light of the day. DG360 is the one I talked about. We took a delegation to Israel. This woman startup is the one only in the cybersecurity. Out of 170 odd startups currently NESCOM registered ones, she was the one, and she really cracked the business deal in while in Israel. Israel, if you crack a deal with Israel, so you have to be really high-end product. Your entrepreneur has to be really of high order in terms of both passion and commitment and domain knowledge, because Israeli people don't really enter into collaboration just like that. Oral scan is for you can say oral cancers. This is a diagnostic tool developed by Sri Chitra incubator, startup incubator. This is a botany for robo. You are seeing this for imparting education, robotic education at school and collegiate level. And I can name any sector. I have numerous examples where women have really made a mark and done us a lot of proud. This was I talked about the Kavach program, and going forward, I think COVID has been a challenging period for us, but let's learn from it as we move forward. We have to in education, I think, whether it's a medical education, engineering education, any education, we have to really work on hybrid models and the the key element is how do you really convert challenges into opportunity. That's the hallmark of being an entrepreneur. And sometimes see many entrepreneurs face problems also. How do you really quickly pivot to new to really take new challenges into and convert them into opportunities, because what you were earlier focusing on may not work in the change scenario. So it has been COVID has been a self-discovery moment, not only for institutions, but for an individual, for businesses, for startups, everyone. It has been a game-changing movement, and there has been a lot of learnings. There have been a lot of silver linings as well. And as we speak, India has climbed the ladder as far as the global innovation index is there. We are in the top 50 club. 48 is our ranking. Ease of doing business in terms of the kind of approvals, regulatory approvals, how do you register a startup or a company, how do you really close your company, all those are being eased out. How do you really file a patent, what is a patent pendency, when it will be given, all are being systematically addressed. And we are currently 63 in the global startup ecosystem. We are number 3, followed by China and USA. And that's how our positioning is. But we have much more potential to perform and deliver. And where we could deliver and really make a dent and impact is up with the new clarion call of being Atmanirbhar and being vocal for local, and couple it with your own state government's mission, whether it's one district, one product, or whatever. So one need to leverage and be really, you can say, a new warrior for self-reliant India. And there are 5 I's included. Inclusion is one, where women and youth are labeled as the 2 key pillars for new India now. So we cannot leave 50% of the population just like that. Only I must say that 3 things are which are required, which can really be instilled and infused is Ichha Shakti, Gyan Shakti, and Karm Shakti for all be it women, be it any citizen. So these are the 3 pillars to really drive the new growth agenda of the country and make India and position India it deserves in the global map. And innovation, nothing can happen. You cannot be status quo. It has to really change. And way to deal with the problems, way to deal with challenges only through innovation, and technology is the backbone. So you need to really leverage. I think being in medical college, I think we had one program, Stanford Biodiesel program with AIIMS Delhi, and our sister Department of Biotechnology, where they had a lot of products made, and it was in collaboration with Stanford University as well. So this program I had seen, I was part of it a couple of years back. So I've seen the kind of product, whether it's a new prosthetic design, whether it's a new, like for fecal inconsistency, there was a product which was designed. So it has to be medical has not to be taken in isolation. It has to be a part of a larger team, and when good team is there, good products are bound to come. So medical institutions are, my suggestion will be really create new role models, bring them to talk to students, because when they speak as a My Story session, it is a different level of inspiration altogether. Listening to all these PPTs will not make much of a difference. The real people who have been there, done that, please invite them, create new set of role models, because they could be very inspiring to students. And that is the first step as an institution. And later on, if you see a sizable, you can say, interest among the faculty, among the researchers, among the students, then you can figure out, okay, what is the next big thing to be done, whether you want to formalize this program through support of any Government of India funding program. That could be the next step. But I think sharing through My Story sessions and instilling that culture of innovation, entrepreneurship, will go a long way in creating that kind of culture in all institutions, including medical institutions, which has a larger connect and role with public at large. And they do a lot of they can relate so very well with the public pain points, the patient's pain points. So that's my thing. So I just would like to, and I like this Rabindranath Tagore's where mind is without fear. But to add to it, I think don't forget what our late President Dr. APJ Abdul Kalam has said, that dreams are not that when you see when you sleep, or dreams are those which doesn't let you sleep. So you have to have that fire in the belly. You have to really dare to dream. So last message is, please dare to dream and dare to realize that dream. Government is there, out there to support you in whatever capacity. So thank you, the entire top leadership of KPMG, the organizers, all those who have really joined in for today's session. I think let us take this as a first step and make every one of us really proud. And I think each of us has a capacity to do even better and bigger and better. So let us not restrict ourselves. Let us widen our horizons. Let us really be observant to the variety of problems. It may not be health tech related. Any problem, and each one of us take a responsibility of inspiring next 5. I think my job will be done. Thank you. Thank you all.
Thank you so much, Dr. Anita, for sharing your remarkable journey where you've been nurturing research, development, innovations. In fact, I feel you've rightly emphasized that the future lies in tapping the unmet needs of society and translating these innovations from lab to the market and the society. And I agree that it is high time that we instill a culture of innovation in our universities. So this wonderful message, I think we take it to heart that we have to join hands and contribute to women power in this Startup India and Stand Up India initiative of our Prime Minister, and the remarkable work that has been done by you. Thank you so much.
Thank you.
Thank you so much for your wonderful presentation.
Thank you, ma'am. So, ma'am, we have one question from Taranjeet Kaur, ma'am. Dr. Taranjeet, would you like
I have to quickly switch over to another meeting. Can I request Professor Divya to really collate all and compile all those? I would be happy to answer them offline as per my convenience. So really regret that I won't be able to take up questions.
Okay, ma'am.
Thank you. We'll take those questions with the next speaker in the panel discussion, and we'll write down to her as well so that we get
so we would like to felicitate you, ma'am, with a virtual token of appreciation. Thank you for being a part of this event.
Thank you so much. Thank you, and wish you all the best.
Thank you, ma'am. Thank you. So we would also like to thank our chairpersons, Professor Abjeet Kaur, ma'am. I think ma'am was here, but there was some disconnection and then she left. So we thank her for chairing the session. We thank Professor Amita Pandey, ma'am, for chairing the session. Thank you so much, ma'am, for being here.
So thank you. Now we move on to the third session. We have Dr. Anita Agarwal with us. Can we have your video on, Dr. Anita? Yes, hi, hello. We are running a bit late in the session. So, Dr. Anita, you are muted.
Yeah, I've switched it on.
Yeah. So let me introduce Dr. Anita. Dr. Anita Agarwal is graduate in chemistry, honors, and masters in organic chemistry from Delhi University. She is a rank holder and PhD in biochemistry and immunology. She qualified NET, GATE, DBT, postdoctoral research fellowship from CSIR and CSIR Scientist Pool. Then she had a research experience of 12 years in the field of biochemistry, immunology, with special focus on cancer, tuberculosis, and anthrax, and has 25 peer-reviewed publications in international journals Can we have the audience muted, please? So currently she is holding a membership position in the technology development board, and she has the components of that board are waste management technologies, advanced manufacturing technologies, science and heritage research initiative, agro technologies, biomedical device, where we all have been submitting projects from time to time. So device development is a main focus, and she looks after those proposals. Now, there's a long list, so but we'll start with
Not
our discussion. Yeah. Thank you for joining us this afternoon. Now, the question we were thinking, we had a lot of schemes from DST. We heard from Madam. Now, as uh, from DST, you know, not many healthcare universities or medical colleges are having their own bio incubator where they have the engineering students and the medical students together thinking on a main component which the students face. So what is your say on this? Do you think it's a good idea that all the universities or medical centers should have a bio incubator, or the bio incubator should be in the engineering colleges and where medical students should go? So what is your say on this?
So, thank you, Professor Divya, for the elaborate introduction. So, actually, I mean, all the audience, they have already interacted with Dr. Anita Gupta, and they know, I mean, they have been apprised about the entrepreneurship related activities which are supported by DST and within the government ecosystem. So, where I am sitting is, I am just before that, where we support technology development programs. I will take you a specific question also. First, I mean, I just want to introduce myself. So we are sitting just before that, where we are supporting technology development programs. And our main stakeholder is faculty and scientists who are working in academic institutions or research labs across the country. So ours is purely like national program, and we are not giving any support to students or to say at the individual level. And the next part is like I am looking after the activities of technology development board also, which comes after entrepreneurship. So once you have startup and you develop a product and then you want to scale up your operations, then you are looking for a bigger funding. You just cannot do with 50 lakhs or 1 crore, which is given by our this board for promoting entrepreneurship. So once you have crossed this level, then if you are looking for scale up of your operations, then we have technology development board, which provides the funding to scale up your activities for commercialization. So these are like three connecting steps. And if you look at DST, so we have basic research promoted by our Science and Engineering Research Board. Then if you go to next level where you are planning to develop a technology, then you come to us technology development programs. So as Anita ma'am has already told everybody, we are sector agnostic. So the main health related research, the main funding comes from ICMR and DBT. So coming to your question of bioincubators, DBT through BioRack, they are already funding bioincubators. I have seen one in Punjab universities. So these incubators, wherever they are funded, they are not meant only for a single organization. So these incubators, you need to have expertise from basic sciences also, or engineering, as well as medical sciences also, if you are looking at any health related technology. So input has to come from clinicians, scientists, as well as engineers. So once this triangle is complete, once all these verticals start interacting with each other and understand the language what other person is speaking, it's not only, I mean, engineers will think from their own perspective. To find everything has to be perfect and it up to the scale. So, but medical professionals like you have to make your judgment on the basis of symptoms, on the basis of the technology inputs that you are getting, the reports and all, which is coming via the mode of technology. And then you have to use your innate sense also to, I mean, for any kind of diagnosis. So medical science or health sciences requires input from like all the sensory organs as well as the technical inputs. So it's very important. So that you, I mean, in order to arrive at any health related solution, you should have inputs from all the streams. So it's a very good idea to have a bio incubator, but whenever you are going for any such proposal, incubator or hub kind of model, you should have spokes in place. It can be in like medical hospital or a medical college premises or an engineering college premises. So, but the integration, the networking, that is very important here. So you should have a good network and good two-way communication, or you can have it a special purpose vehicle away from all the campuses and a place, put it at a common place. But the free flow of information and free interaction in all stream is very important to arrive at any technology, product or services. So you can, I mean, it's a welcome move if you have it in the medical hospitals and engineers go and work there. Because there only they will be able to observe the unmet need. And as Madam has already pointed out, India Stanford Biodesign Program. So that program is housed in AIIMS, Delhi. So that is how the students were able to realize the medical needs in the clinical setting. And then they have come up with innovative solutions for unmet medical needs. So I think it's very important to have such facilities in the medical colleges if you are looking for some solutions for unmet needs. Because in engineering premises, engineering colleges, you will not be able to observe in actual real settings. So that's a good idea. And DBT is supporting bioincubators in medical colleges. And from our program also, from biomedical device and technology development programs, we have supported 2 hub facilities. First facility was created in engineering college, Anna University. And there, when we felt like if you want to engage clinicians and you want to have their inputs, because I mean, development can be done by engineers, but whether acceptance of clinicians is very important to take any health technology forward. So, I mean, with our experience, we started the next facility at PGI Chandigarh. So they are also working on innovations in the area of biomedical devices and technology now. So this facility was started 2 years back. And right now we have completed 2 years and already they have come out with the 2 products. And one is already going to the market. I would say their pace is not as good as an engineering college, but still the solutions that they are coming up have a clinical stamp and clinical validation. So all the medical fraternity is like willing to accept those solutions. So with my experience, I can say it's a very good idea to promote such innovation facilities and research facilities in medical colleges.
What we see that as faculty members, we know of the schemes, we apply for those fundings and we do our project. But if we want that information to seep among our students, if there is some center where they can visit, that can accelerate their thinking, that percolates among the students that yes, this is an area where we can go and think and discuss. So that sort of thinking hubs are required because
no, Atal Innovation Labs, Atal Tinkering Labs, I mean, that program was initiated for that purpose only. So I think you can very well apply for those Atal Tinkering Labs where your students can interact with each other and have free flow of information.
Yes.
Because
so I think
this, yeah. So this kind of experiment has proven to be like very successful. I have seen one such facility, although not in medical premises, at CPEC Bhubaneswar Center. So CPEC is an institute which focuses on plastic this manufacturing. It's associated with Ministry of Chemicals and Fertilizers. So they have created a full floor. I think it is more than 3,000 square feet area only for this interaction. Where students and anybody can just go and interact with each other and tinker and work on the ideas. So until and unless you create an environment where students or the faculty can explore the ideas, you don't need huge funding for that. Maybe 20 to 25,000. In our PGI hub at Chandigarh, we have given that room and we have given that component to work upon ideas. We have given them only 50 lakh rupees. So with that, they can just explore the new ideas. The faculty, students, whosoever is interested in exploring their creativity, if something comes to their mind, at least a part of it, design part or some kind of like Krug experiment to prove your concept. So that can be done in that facility. So this kind of facilities are definitely needed in the country to encourage young and creative minds to explore their creativity.
Thank you. Now, what comes to my mind is what is the expectance? What do as you as funding agency expect from the institution like us? So, how to have a better collaboration? So, what are your suggestions for us?
So from any institution like you already enjoy a good reputation as far as your services is concerned. So you have the credentials to do better. You have already been doing a lot of research work, which is like accepted in peer group reviewed publications. You have good impact factor. And as far as my experience with your institute is concerned, we have given you 2 technology development programs and the delivery was good. So whatever you have committed, you have fulfilled those objectives. But right now, those developments which are, and there must be many more similar developments which are lying on the shelf in the institute. So now it is for us, it is the collective responsibility of the community. How do we take it forward? Because as a clinician, you are doing your practice, you are attending your regular patients also, but still you all have contributed towards the research and development of those products. So a doctor cannot, we do not expect our trained doctors to leave your practice and then go to market, run from pillar to post to take those products forward. So incubation centers are very much needed over there. And since I have been handling technology development programs, so far we were working on the conventional model. You have industry academia together, they apply for the project and the product is developed by the researchers and it will be directly taken to the industry. But the model has been, the traditional model has been unsuccessful. So right now for our programs also, we are exploring once we have developed this product, how do we take it forward through the startup? The other problem with the conventional model is nobody has any technology transfer guidelines. The institutes, they don't have. Even the country we don't have any technology transfer policy or the guidelines. Then how do you take it forward? So the industry, they fumble when they interact with the academia because it's a long process. But they are very comfortable interacting with the startups. Startups can be easily bought out by the big companies and then they can just take the product forward. So that is the route now we are also exploring in our programs. In DST also we have different verticals, but we have never thought of horizontal integration. But looking at the demand of the situation, now we are also thinking of this horizontal integration. Now we are also trying to push our developments into the startups or the business incubators which have been created by the department and then see how we can take it forward.
Yes. So other thing which I wanted to ask, like besides the financial support DST provides, is there any form of other support which like training, etc., towards innovation? So how do you support or make awareness among students? So that is where we want to.
Exactly. So if you want to have any such program, you can take the funding from NSTGB. Anita Gupta ma'am was presenting her program. So under Nidhi umbrella, they have a provision to give funding for training in the area of entrepreneurship. Or generally, if you are looking for any other training program, so you can go to Ministry of Skill Development or you can contact our Science and Engineering Research Board also. So they have this, through incubators also, they are giving this training funding for the training programs. And directly also, they are funding the training programs, like if you want to do it for encouraging the entrepreneurship. So that kind of support is available from the department.
Thank you. Thank you so much. There's one question from Dr. Monica. She is trying to ask. Dr. Monica, can you put forward your question?
Yeah. Thank you, Dr. Anita, for a talk. See, what I wanted to ask is, as a professor, we develop something, but we do not know the and we may not be interested in this entrepreneurship because that will take us to a different ending. So, do you have some so that people can take up those things and take it forward? maybe it may be difficult for me to invest that much of time that I find a person who is ready to manufacture it, take it to the market. So is some mediator kind of a thing can be promoted?
Yeah. Actually, through our hubs that we have created at Anna University and PGI Chandigarh. So there is a platform for technology commercialization. So we have given them a separate component, part of funding for taking the innovations from anywhere in the country. They can take it forward. So they have a pool of industries with which they are interacting. Then we are interacting with IMEG also, Medical Device Manufacturers Association. So through these people, definitely we would like to push such development forward. So as I said earlier also, every professor does not have appetite to be an entrepreneur. And neither have they have time nor the appetite. So one thing is when you are taking the students, you can encourage them to go through the route of entrepreneurship, or definitely you can simply license the technology to any industry and get away with it. Or you can use these mechanisms like NRDC is there. So they help in technology transfer. So you can approach these agencies which are already existing in the government system who help you with the technology transfer and commercialization. Or you can go through our facilities also. On similar lines, we have created technology enabling centers also. And for these centers, we have focused only university systems. So in the pilot study, we have created 9 such centers throughout the country. So the idea of creating these centers is just to push the innovation ecosystem. And these centers, they interact with the local industries which are in and around them. So they also facilitate the technology transfer. They help institute or the universities in their region to frame the technology transfer guidelines. Because this is a major impediment to when any industry approaches you, then the cost of technology is so high which is not worth it. Like people will include the salary of peon also, everything, so the technology cost is blown out of proportion, which is not affordable for the industry. And the second point that should be taken care of is hand holding. So it should not be like if you are a developer and you have transferred the technology, so that should not be the end of relationship. So you have to hand hold over a period of time till the product comes out and it goes to the market. The hand holding and the value of death when the manufacturer is trying to productize your development is very important.
So some other question is apart from DST side, apart from innovation and entrepreneurship, specifically for women scientists, there are certain schemes. If you could,
yeah, definitely. From DST, right now, the latest what we are doing is, so as Anita Gupta ma'am has already mentioned, we have a Kiran program in DST. And that is again sector agnostic. All the sectors are covered in that. So right now, the latest initiative is they are forming like gender inclusion framework for rating the institute. It's a kind of accreditation, and the advertisement will be out either today or tomorrow. They are going to give it out. So this is gender advancement transfer for transforming the institutions. So this is Gati framework which they have created, and we will be implementing it soon. And in the first pilot study, we will be looking at 25 institutions. So already we have SWAN, Athena Network in Australia, Canada. They have all this the institutional frameworks which are looking at the gender parity in the respective institutes. So here under Gati program, so we will be looking at the progressive action-oriented, time-bound self-assessment process, which will be opted by the participating institutions, how they are enabling the women in their institutes. So that advertisement will be out soon, and we will be very happy if your university participate in that study. So you will be given some money for conducting the training programs and all that for women awareness. And apart from that, you will get an accreditation also in under the program, and plus some money for research also, I think, will be given. So you can go through the fine guidelines. Then we have under Kiran, we have 3 schemes for women scientists, WASAVE, B, C. One is for doing the basic research, and these all schemes are for the women who have break in career. And the second is for the societal relevant research.
But why should we wait for break in career? Because sometimes it happens that the SRship is over and they want to continue, but then they have to have a break in career to
Very
get,
true. Very true. And then DBK has a biocare program, then that is only for the first timers. But in long run, I have not seen any specific scheme for the women. We think in science and technology, women are already enabled and empowered, and they can very well compete with men. So for my program also, we have around 45% projects which are coming from the women scientists for technology development. So we just don't see that heat, that gender problem as far as our this scientific research is concerned. Although there is a dropout, as Madam was saying, after college education, in educational sector there is a dropout. But when it comes to participation and applying for the project, so there is not huge difference. So it's not 20 or 80.
I was also seeing in my university what is the ratio of students. Then I found that in MBBS or BDS, there are 50% or more than 50% students.
Right.
Then when it comes to PG, then also you have a lot of female students. But then super speciality, very few. It's 1-2% only. That's the ratio.
No, but whosoever reaches that level, once you have reached that faculty level, then I don't think as far as scientific research is concerned, there is any huge gap or huge wide gap.
Yeah.
So, I mean, we are supporting from my program around 40% of the projects, they are going to women only. I mean, it's not that consciously we are doing that. It all depends on the input. Right now, for our biomedical device call, we have received 242 proposals. And out of that, I think 105 some odd proposals are from women. So then in that case, there is no need to run women-specific schemes for such programs.
And if we talk about the technology development program, what do you see? How many projects, if you compare the engineering side and the medical side, how many projects come from the engineering side and what is the proportion coming from the medical side?
Okay, yeah, that is an important question. So out of those, say 240 projects, so hardly 30 projects, it's almost like 15 to 20% are from medical side. And those are also, some of them are really too rudimentary to be considered for funding. So if I look at that ratio, that is really, that is thought provoking and that really needs some working on that aspect. So for any kind of
that focuses that the medical centers or the medical institutions need to have that training imbibed into their curriculum. Yes,
precisely. So that is where we are lacking. I don't think gender is an issue here, but as far as the proposals for technology development or product development is concerned, definitely, I mean, medical colleges or medical institutions, which are institutions of eminence, they are certainly lagging behind. Like most of the biomedical device proposals or medical technologies proposals, they are coming from engineering colleges. So the participation of medical colleges is only 10 to 15%. And that too as a partners, not as a leaders.
Yes.
So that is where we need to work upon and we need to create and push the ecosystem.
Yes. So this is what I was thinking of. If there are any questions from the audience, please come up with your questions. Is there any?
I'm not in the chat box.
Okay. Any student wants to ask anything? Ahmed, I see you very inquisitive on asking questions.
Dr. Monica has put in something. Can I ask? So
yes, please.
So, ma'am, would you like to ask something?
I have asked.
She has already asked.
Okay.
Okay. So this is regarding education again. So one more question: is there any plan
Yep.
to integrate entrepreneurship education in our Indian education system. So is there any plan from the DST or DBT or
You see, we are not into the education. Like primarily, all these funding agencies, we are funding research. And as far as education is concerned, Delhi government has taken this initiative, and our class 9th onwards, they have added entrepreneurship in their curriculum. And in my opinion, I think you have also have autonomy. And time to time, if you're not integrating into your curriculum, then you should have some kind of training programs which are supported by the department, and all other Niti Aayog and all, they are also supporting such training programs. So it is very important to have those programs to conduct your day-to-day life business also. Even if you are not going for the startup or something like that, but still, again, as pointed out earlier, all the clinicians who are doing their work, they are entrepreneur in themselves. So in order to, promote that skill set, so many of your students, they will be going for private practices also. They will have their own clinic. So it's always better for, it's good for them to have some flair of entrepreneurship. See how they can grow in their stream, how they can grow in their business also. So everybody, so many students are passing out every year. Everybody will not get a government job, and after retirement also, like all the faculty, they go for private practices. So in order to have you create a mechanism or create something on your own, it's always good to have a formal training and understand the nuances of the business. And
So
it's always good. Yeah.
as per you, what should be our first baby step? The first thing we should be looking at, that this is thing where we need to start.
So the starting point could be you can start off with the training program. So that is the first and foremost thing to do. Then the second is you have to exhibit your innovations to the larger community, and then see who is willing to take it forward. So once you have few of such people who are willing to go for a startup, who are ready to take this innovation forward through the route of entrepreneurship. So then you can have your incubator or a center in your premises. So it's just that you have to take baby steps. So first of all, you have to create that ecosystem. And I think you must be having enough models or enough products which are almost ready, which can be taken out to the next level. And many of the startups, people start from the idea. But if you have a ready product and you have the stamp of the doctor or clinician, so I think it is easier to take it to the next level and to the market. And when government is giving through so many schemes, so for that you can explore your neighboring incubators also. So first and foremost is you have to push the products or the technologies which are already sitting with the faculty of the institute. And then for the student ideas, you can get some funding from DST or any other department to promote these innovation camps on a regular basis, where students can explore their idea and convert into product. So, everything, every little step you are going to, or you can organize these hackathon kind of things. So our PGI Hub Chandigarh, they are doing a lot of such activities. So for the area, from starting from the school level and common man to the clinicians, they are organizing these hackathons to plug the ideas which can be converted into some useful products. So those kind of events, they are very important. And at least they will compel your faculty to think out of the box and think something new. So initially, I used to think this is all a waste of time. But with my experience over the years, whosoever wants to do something, they will do it. But once you see the ad and you see something, so sometimes it clicks you. Okay, fine. At least event is happening. At least let me go and see what is going on there. So that gives encouragement to many people. And the publicity is very important so that it reaches to every nook and corner.
Yes.
Okay, once people see, yeah.
We
So
also
those
did one hackathon sometime in Feb. We had a
yeah.
UK India partnership program, and we did a hackathon, and we got about 15-20 proposals. So finally, we are in collaboration with them, and then we are helping them out to nurture their idea further. So let's see.
So this is a very good starting point for you. Now you should have an entrepreneurship training program also for those 20 ideas that you have selected, so that from the beginning their mind should not be corrupted and put on the right track. So this is, I mean, once you have selected such people, so you should, I mean, try to groom them in the best possible way. So every year, if you keep on doing this, so you will have a like nursery of such people who can promote this kind of activities. So then it itself is like a nuclear reaction, nuclear fission reaction. It is self-propagating, and you don't need anything else to sustain it. Like Madam has missed that point, but some of our incubators, they are so successful, they are making money like anything. They don't need any kind of government support anymore.
Yes, if you heard Dr. Shelly Awasthi in her inaugural talk this morning, she said what should be the criteria of evaluating this innovation. So is this making money, or is it how much helpful it is for the society? So
I
that
think
was a
there
good
has
question.
no. It's a very really pertinent question, but I think both are equally important. So impact. So if it is reaching out to society and it is making a huge impact, then naturally you will get some returns out of it. It's not that any incubator or any company cannot run on like no profit, no loss model. So this is not charity that we are doing, and people won't value it if you give them free of cost. So some price tag has to be attached to everything because innovation comes at a cost only. So making money is important, but at the same time, society outreach is also important. So once you get back the money, at least you can put that money for supporting new innovations. So if there is no return, then how do you plan to sustain yourself? See, right now, government is in a mode of promoting startups, but down the road, after 10 years, you don't know what the policy will be. So whatever model you are proposing, so you have to look at the sustainability of that model also. So right now, everything is conducive. Everybody is talking about startup and giving money, and everybody has jumped into it. But you don't know what the situation will be down the road after 5 years. If government withdraws the support, then where will this innovation business go on? So we have to be pragmatic in our approach, and we have to strike a fine balance. And if innovation has a far-reached value, and if it can reach out to the nooks and corners of the country, to the society by and large, it will fetch enough revenues to sustain itself. So we don't have to worry about that too much.
Thank you. It was wonderful. You solving our queries. Thank you for yeah.
It's always my pleasure to interact with KGMU as far as I'm in on the technical front also. So we have sought help from so many experts in our programs from your university. And Lucknow is especially, I mean, my message is Lucknow is a very conducive place. We had once meeting of around 51 institutions which are in and around Lucknow, and there were I think 4 medical colleges also. So it's all about networking. Like if you can have good networks with these institutions and you can help each other, then I think I don't see any other place where within the geographical vicinity you have such a good density of institutions and really good people, good science and good technology, and very strong technology base is existing in all these institutions. So it's very important to get them together on the same platforms, have such kind of interactions with these institutions rather than the funding agencies. So you can really come up with some good innovative products. So Lucknow can be a model city to produce, fuel the startup programs.
Thank you. Thank you so much for your guidance. Richa, can we have a appreciation certificate, please?
Thank you.
It's all virtual. It's coming up. It's not yet there.
And
Yes.
special thanks to the authorities of your university, KGMU, and your Honorable Vice Chancellor, and you. And my special thanks to Professor Mehrotra and Dr. Richa for giving me an opportunity to interact with the wonderful audience. And I can see we have a very good number of audience throughout the program. Thank you very much. Thank you, one and all.
Yes, the program students are all on YouTube. So students are not here. This is the faculty only.
No, but an attendance of 50 throughout the webinar is really good. I've been there through inauguration also. So I'm really happy to see that. Thank you very much.
Thank you. Thank you. Thank you so much. Who is the moderator for the next session?
Just a minute. Ma'am, Anita Rani, ma'am. Ma'am is here.
Dr. Anita, would you like to take over? Dr. Anita, are you there?
Good afternoon, everyone. Ma'am, could you please open my video?
Oh,
can you allow just my video to be?
Ma'am, you can.
Richa, can you please do that?
Yeah, ma'am, you can do it yourself as well. We have requested.
Okay.
You can just click on that icon of video and it will.
Yes, I'm clicking it. It is showing cross onto it and it's not opening. I don't know why it is.
Okay,
so,
okay. Proceed. You may proceed, please.
You may. Okay.
So, can I start the session? I know that people are not able to see me.
Yeah.
Can I start the session?
Yes, please. Yes, please. Yes, please.
Okay. So we have our chairpersons here with us, Professor Shraddha ma'am from the Physiology Department. She is Professor of Physiology. And we have our chairperson, Dr. Tulika from the Transfusion Medicine Department. She is the head, professor and head in that department. And now I'll request Professor Shraddha Singh ma'am to kindly introduce our respected speakers, Professor Monica Agrawal from IIT Delhi. Professor Shraddha ma'am, over to you, ma'am.
Okay, thank you. Thank you, Dr. Anita. Am I visible?
Yes.
Yes,
Am
I
audible?
Yes, you are.
Okay. Okay. First, good afternoon to everyone. I would like to thank the organizers for giving me the opportunity to introduce the renowned speakers. Today is a special day, that is a Women's Entrepreneurship Day. I would like to introduce the Professor Naseem Ghazali, who is duly qualified in dentistry and medicine. She has completed her maxillofacial surgery training from London, Eastman Dental Hospital, UCL King's College and Guy's Hospitals, Royal Surrey Country Hospital, Guildford and Queen Victoria Hospital, East Dean Estate. She was awarded a clinical research fellowship in head and neck oncology at N3 University Hospitals, Liverpool. She has completed a surgical fellowship in head and neck oncology and reconstructive surgery at University of Maryland, Baltimore. Professor Ghazali, as the leader of Research and Development Maxillofacial Department at ELHT, her research interests are in head and neck cancer, particularly outcomes research, that is functional and quality of life outcomes. She has been awarded with research grants in this area of work. She has widely published as many as over 35 peer-reviewed papers and also has written a book chapter. She has been an invited speaker at several national and international surgical meetings. Her future areas of research include transoral robot surgery and oral pre-cancer dysplasia. She has received many professional memberships, and she is also a prestigious member of British Association of Head and Neck Oncology. So I must appreciate her achievements, I now invite you for delivering a lecture. Welcome, ma'am.
The first speaker, Dr. Shraddha, is Dr. Monica. Could you introduce her?
Dr.
as
Monica is the first speaker.
Yes.
Oh, okay. Sorry.
That is
But
okay. We can exchange also. That's fine.
Achha.
I don't know if Dr. Naseem is here.
I have been told that the first speaker, Professor Naseem Ghazali. Okay, I introduce Dr. Monica Agrawal.
Monica, please. Yes, please.
Okay.
Yes,
I
please.
introduce. Okay. I am introducing the Professor Monica Agrawal. Okay. Professor Monica Agrawal received the BTech degree in Electrical Engineering and MTech degree in Electronics and Communication Engineering from Regional Engineering College, Kurukshetra, India. She was awarded the PhD degree from the Indian Institute of Technology, New Delhi, India. She was working with Yug Software System, Gurgaon, India from 1999 to 2002. And during this period, in 2001, she was visiting researcher in the Department of Systems and Control, Uppsala University, Uppsala, Sweden. She joined CARE, IIT Delhi as assistant professor in January 2003, and now presently she is working as a professor. So I must appreciate her achievements. I now invite you for delivering a lecture. Welcome, Professor Monica Agrawal.
Thank you, Dr. Shraddha Singh, for this introduction.
First, I
Thanks a lot.
Okay, it's all right.
Yeah, that's okay. See, it happens. It's an online mode. We all are meeting.
Online mode, yeah.
Yeah, it's so much a confusion there. So that is okay. So I think I'm an odd one out in this settings. I should thank Dr. Divya for giving me this opportunity to talk over here, and all the organizers from this university, King's College, for organizing this wonderful event on Women Entrepreneur Day. As a woman, we kind of need an extra push to do everything that we all know. I mean, working from home for us is work from home and also do the office work. So it's all more difficult. I think you, all the doctors, are also kind of taking care of hospitals. So your burden is, I can imagine, is much more. So it's wonderful here to be here, part of this event. So I'm actually talking about what I am presently doing, and I'm also trying to collaborate with Dr. Divya on some aspects. So my topic today is, I wanted to talk about this artificial intelligence in the domain of medical sciences. My slides are visible?
Yes.
Okay. So good afternoon. I start. So basically, what is an artificial intelligence? I think we all know.
You may put it on slideshow, please.
Okay, I think slideshow.
Yes.
Is it visible?
Yes, now better.
So, yes, sorry. Artificial intelligence is actually making machine think. We all know that. So we want to make machine take some decision and also do some problem solving like we human do. But the intent is that we want to make machines smarter than human. So that is an intent. When my grandma used to tell me the stories of Ramayana, I used to wonder how Jatayu was speaking and Ram could understood the language. It's actually a bird talking and human understanding. But today, when I made a system which could translate languages, could understand, I can understand that could happen. So basically what I feel is, in the olden era, our sciences were much more developed. At Mahabharata, Sanjay telling a live commentary of Mahabharata to Dhritarashtra is nothing but a live telecast, which we all do today. I mean, we are connected, so we can see that happening. So those things are happening, and we are kind of innovating them again and again. Kunti having 100 sons is nothing but maybe an IVF. So her eggs were fertilized and she could have 100 kids. So those are the things which are there in our Vedas and which we are trying to make it happen. So this artificial intelligence is also making us do that. Basically, VAD used to hear your pulse and tell everything about you. Even now, my mothers look at my eyes or sometimes hear my voice on the phone and she tells me that, oh, you're not well. You should take some rest. So how is it possible? It's possible because of some senses that the parents or they have. So the same thing can be imbibed into the machine. That is what an artificial intelligence we want to achieve. We have driverless cars. We have people, robots picking up the ripe tomatoes. There are numerous of examples we all know which are circulating, that these are the things which are able, the robots could do, the machines could do, which were only being done by the humans a few years back. In the medical history, if I start, in somewhere in 1970s, people started using artificial intelligence while using the antibiotics, that which antibiotics should be used. But nowadays, the era has totally changed. We have personalized diseases. We have artificial intelligence in the everywhere. In the cancer is one of the kind of a killer disease which people used to think. And in 2016, the US White House took a decision that they should remove the cancer and they should use all possible aids the technology is giving in removing that. That has given a new era has started, and AI into the medicine has took a place. If I look at today, the AI in healthcare, there are so many verticals that are there. We have chatbots, we have wearable devices, we have mental health, we have telemedicines, we have genetics, which also takes care. We have a personalized drug. So it's everywhere. The medical AI is playing a role in the medicines. Many big players are also investing. Not only the big players, there are thousands of startups which are coming up with new and new devices everywhere. We also started working in the area, and as I told, necessity is the mother of invention. So this happened with me also. So we try to design a device which can actually do a remote lungs examination. My father is a 80 years old asthma patient, and taking him to a doctor sometimes becomes too difficult. So why can't we have a device which can do a remote lungs detection? And then when we thought about that, we went along and we thought that why can't we add other things to it? That present stethoscope can only hear what we hear from the sound from our ear, but there might be other frequencies, the other signals which the body is emitting, which is not being heard by the doctor. So we can add it. So we are trying to add some extra features to the stethoscope so that it can do better than a machine which is present, and it can provide a more aid to the doctor. We are trying to incorporate the ultrasounds also into it, so that an active source can be present which can transmit the signal, and then we can get a single device which can be your which can give you a complete scan. Another thing that we are working on is the retinal things. We collaborated with AIMS because I am in Delhi and AIMS is the nearby place. So these retinal images, my mother is a patient of AMD, which is a age-related muscular diseases. And we belong to a very small town, and there the doctor could not diagnose the disease. And she had to lose her vision of one eye because of that. So that made me do something, and we are trying to design some tools. I think now they are in a very advanced stage that we can do a diagnostics which can help the rural area where the doctors, these specialists are very rare in number. Along with Dr. Divya, we are trying to work on this detection of the oral cancer. During the COVID, we got some images and we saw that these COVID lungs are much different from a pneumonia lung. And we could make some image processing tools to kind of do the diagnostics of this COVID using these lungs X-rays. I mean, so basically, I am not a doctor, but what I did is I just used the data which I got from somewhere and trained a machine so that machine can understand and machine can give me the diagnostics. So it's just a training of a machine which has been doing all this. Now, what I feel is the AI can shape the future of healthcare in many ways. This brain-computer interface, we all know, can a neuropatient use this interface and can speak when he's not able to speak and can get those senses back? So this is possible because of the AI. The thoughts of the person can be read by some sensors and some speaker can be so that he can speak. Can we provide these diagnostic tools at the places, at the remote and the rural areas? Can we, because of the connectivity, we can reach at to remote. So the COVID, what I feel is a real promoter of a digital world. Now, most of the doctors and we are teaching online, we are meeting online. So why can't a telemedicine be done? Why can't a diagnostics be done? If we have an equipments there and the reports can be generated or a diagnostics can be done, so that is possible. I feel that in coming years, we'll have so many gadgets of medical devices and the machines which can change the complete world. Even the records that we collect, the records of the every patient that we have, if we make them electronic, can we use them to do the diagnostics? My today's record can predict what is my future. How will I see? It's today what I'm eating. What is my medical condition? It has its impact on my future. So can this data be used to predict my future? And then what I feel is there should be something by which my mother can guess my health by looking at me. There should be an app, there should be a tool that can by taking a selfie of my which can tell my state of health. So that is what the AI is coming into the picture and changing the world. But there are many challenges. Because these will give me a complex technologies, and we need a competent and professionals to implement it. We also require some bioethics while implementing them. The acceptance among the people is also a questionable. Many people still feel that only doctors can treat them. The machines and other things are not able to diagnose them. So the acceptance among the people is also still not to that level. It is something like computers. When we were growing, the computers were coming into the pictures, and everybody was thinking, how do I remove this register that I have to a computer? It will change things. I should not use computers. But things have changed, and it has changed for good. So this change is also for the good. But even though we change everything, things cannot go without the doctors, without your contribution, because I don't know when the things will come that AI can provide the empathy to all of you, to all of us, that doctor gives. Thank you. That's all.
Thank you, Dr. Monica, for enlightening us regarding this artificial intelligence. Now, I would request Dr. Tulika to kindly introduce our next speaker, that is Professor Kathy Fan. Dr. Tulika, over to you.
Okay, thank you, Dr. Neeta. And first of all, a very good talk by Dr. Monica, really appealing. And now I would like to introduce the next speaker, Ms. Kathleen Fan. She is the consultant oral and maxillofacial surgeon, and her degrees are PhD, BDS, MBBS, FD, SRCS, FD, SRCRC, ED, FRCS in OMFS. She is consultant oral and maxillofacial surgeon, King George Hospital, and a reader in oral and maxillofacial surgery in King's College London, and council member of British Association in oral and maxillofacial surgery, national media and communications. And she is a member of the dental subgroup committee and council member of British Medical Laser Association. And she's done PhD in 1998 from University College London, BDS in 1990, that is from United Medical and Dental Schools of Guy's and St. Thomas Hospitals, University of London. And she's completed her MBBS in 2000 from the Royal London and St. Bartholomew's Hungaria University Hospitals, University London. And she's done FDS RCS in 1993 from Royal College Surgeons, England, and FRCS Edinburgh in 2003 from Royal College Surgeons, Edinburgh, and FRCS OMFS in 2007 from Intercollegiate Specialty Examination. And Kathy is qualified from Guy's and St. Thomas Hospital in Dentistry and Medicine from St. Bartholomew's and the Royal London Hospital. Her PhD was in photodynamic therapy in head and neck cancer from University College Hospital. She undertook her specialist training in London East Grinstead and Kent, and was appointed as consultant in 2008 at King's College Hospital. She has been a member of Department of Health Working Party on PDT, NHS England for management of unscheduled dental care, and with BOMS for preparation of national guidelines. She is hugely involved in mentorship of medical and dental professionals from school through to completion of training. That's good. She is an author of numerous educational textbooks and peer-reviewed clinical papers. She has PhD students working in tissue engineering of craniofacial structures. Her subspecialties are orthognathic surgery, skin cancer, photodynamic therapy, craniofacial trauma, dentoalveolar surgery, scar revision, and TMJ surgery. And outside of her clinical practice, she has extensive research interest. She is involved in medical and dental education at KCL. She was awarded the BAOMS Surgical Prize 2016 for major contribution to oral and maxillofacial surgery. So I think so that's a huge set of achievements, and we are very happy to have you over here with us and really interested in hearing your talk. So please take over the mic and continue, Ms. Kathleen.
Thank you so much for inviting me to speak at your conference, Dr. Malhotra. I will go into screen start and one moment.
Yeah.
Can you actually see the slides?
Not yet. It will take a second.
Okay. Let me just see why it's not doing that. Let me see. Have I got the...
You are the co-host. You would be able to share it.
There is no sharing facility at the moment. Is there something you need to release to let me share?
No, I have done that. I've made you co-host. So you have to just look at the bottom row, and in the center there is share screen icon. Green one.
Yes, it doesn't seem to be coming up for some reason. Okay, let me think. Let me shut it off and start it again and see if that's why. So I had the presentation open already. Let's try again. Okay.
Yes, it's coming now.
Okay, in that case, I will go to slideshow. Apologies for that. Okay, so thank you very much for inviting me. In terms of innovation entrepreneurship, I have to confess, as a surgeon, we're probably guilty of not pushing this area as much as we could do. But in terms of how I've thought about what's been done in other aspects of medicine and dentistry and how we've brought it into oral and maxillofacial surgery, I thought that would be an area I would speak on. So I'm based in London, and these are some images recently in London. London's very rarely this quiet, but unfortunately due to pandemic, it's quiet. As you can see, and our streets are actually fairly empty. We have our main tissue engineering lab is based at Guy's Hospital, which is at London Bridge. And this gentleman is John Keats, who was a medical student at Guy's, but then decided not to finish his medical school training and became a very famous poet. So moving on. So the areas that I'm speaking about today is very much on tissue engineering within the craniofacial area, in particular, temporal mandibular joint. So temporal mandibular joint disorder is a common problem, and most of those we manage quite conservatively. We treat it with analgesia, splints and what have you, and very few come to us as surgeons. Only probably 10% of those referred come to us and actually need something done, either a washout or an arthroscopy, where we can either just have a look or we can actually do something therapeutic in there. And that's relatively successful, and so even a smaller percentage actually proceed to actually needing something more in terms of open surgery. But for these patients with end stage jaw joint problems, they're troublesome. We as surgeons don't really have a lot in our armamentarium of dealing with these, and essentially it was during one of these cases of having to do a total joint replacement, which you can see an image there. I thought, gosh, this is incredibly destructive. The patient obviously needs to be able to function, they need to be able to eat, but I thought there must be a better way. And I looked at what our orthopedic surgeons are doing, and they have embraced tissue engineering, and we are somewhere going in that direction, but we're not quite there. They're doing it already, so we're a little bit behind, but it's always good to follow and see what someone else is doing in a different field and bring it into your own field. So I thought, okay, so we do minor procedures already. If there's some osteophytes, if we may decide to do a high condylar shave, we may take the disc out, or we may plicate the disc, but we don't do regeneration. We haven't, not to any extent. We know that it's done in the knee. They've got little defects on the cartilage. They will actually do localized treatment in there. And I thought, well, why not? There's no reason why we, as oral and maxillofacial surgeons, can't go in this direction of minimally invasive surgery. And that's essentially where one of my PhDs, well, two of my PhD students, one has just got his PhD, and this is part of his work. So our thought was, let's look at resurfacing the TMJ with cartilage and bone, and let's not be so destructive. What my brief was, could you identify a scaffold that you could actually potentially prepare that we could use in theatre in an ideal situation, down a scope? In that, I want you to be able to deliver a scaffold, put in stem cells, so that actually we can actually initiate some regeneration and repair of cartilage and actually bone as well. So I would like to have a bilaminar structure if possible, cartilage with bone underlying. That was my brief to him. So this is where he started with looking at the anatomy and realized, okay, the cartilage, even in a healthy state, is quite thin, and certainly in our unhealthy state that we would see as surgeons, is not going to be there, or not very, not in any sort of identifiable identifiable form. So it's normally only 0.5 millimeter or so, and it's fibrocartilage. So so he set off on his endeavors with a plan that where in the patient state, the damage area, I would want the damage area of cartilage and bone to be removed, and then I would want the scaffold and stem cells to actually be placed in. The first difficulty was I wanted the procedure done under a ideally minimally invasive with under arthroscopy. Although when we first take it into clinical into the clinical phase, I'm sure we would be doing open joint surgery, but nevertheless I felt it was sensible to go for the ultimate aim. So I already use hyaluronic acid as part of the arthroscopy anyway, so I thought that's a good way to, place to start. Use a scaffold base on hydrogel, hyaluronic acid. However, that's really liquidy for those of us who use it. It's liquid. You can't sort of flush it into the joint and expect it to stay within your defect that you've created. So that was the first problem, is how we can make this hydrogel actually packable. I almost thought, from my dental background, pack it into the cavity and make it firm. So I said, well, can you use something like we would with restorative material? With the blue light, we use that for composites. It's, it's where you use your medical and dental knowledge together. And so that's where he went. He looked at hydrogels. How could he actually make it firm so that you could pack it by using pack it and then using light. So that's a methacrylation that he had to work out first of all. Now, just packing this material is one thing. Actually, it's got to adhere to the base. It's got to adhere to the bone underlying, and if there is any cartilage on the lateral aspects as well. And it also has to deliver the drugs. It has to deliver the stem cells, and within this, we need to have mechanical sensing, so that actually these stem cells need to know that at the bottom I want bone, at the top I want to have cartilage. So these are all things that he had to think about. So I'm hoping it's going to work. So his first thought was, okay, Kathy wants to have something that will become solid enough within water. So he had to kick off with a hydrogel and set up an experiment which would allow him to get the hydrogel to actually become solid within a liquid environment. So this is actually glass tube. It's got water in it. He's had to modify with different concentrations and methacrylate to actually work out what is the ideal concentration to actually produce a solid gel that I can actually put my finger on. And I remember him giving it to me, is this thick enough? And I said, yeah, okay, that's good, but it isn't going to stick. So the next stage of his experiment was, how do I do that adhesion? How do I get this hydrogel in to adhere to the actual defect that will be created in theatre, be it by open surgery with a drill or a laser, or down the scope, and we can do it with both. So so this was his next step. Of it needed to stick. So he then had to look into dopamine and different concentration of dopamine to actually get the hydrogel to actually stick to the surrounding tissue. And you can see that now this hydrogel, which is here, is actually sticking to some tendon and muscle. And it's more difficult to show on bone. That it was easier to cut through this. But with that in mind, we thought we're getting somewhere towards it, but it's not going to be very helpful for me if actually we can't put the stem cells in, and we can't change the environment to actually create this cap of bone and cartilage, which I was envisaging for these degenerative joints. So he has then moved on and actually looked at cytotoxicity sort of profile of having the hydrogel along with the stem cells, and one can see on the left hand side that you can see actually there are a number of actually green viable cells. So the environment that he has created is going to support the action of the stem cells. However, be mindful, there are the odd non-viable cell, and as he changes the formulation, one can see that there's slightly less of the magenta cells. Having viable cells is one thing. These viable cells have to secrete, it's got to secrete some protein, which is going to either become cartilage or it's going to be bone. And so he had to move on to the next stage, was to make sure that these cells, within this, in vitro situation, that he could actually, his cells was able to produce protein, and that's where we are at the moment. So in terms of what I had, in terms of what my brief was to Chris, can you form, can you produce something for me that we can utilize in a clinical situation? It seems all very quick when I put this all together. He has worked with a number of clinicians, and I seem to have lost my slide of the clinicians. So we have international collaboration with Gerhard Unt, who those of maxillofacial surgery will know. He is he really is probably the best person, or if not the best, one of the best at most skilled individual doing temporal mandibular joint arthroscopy. The things he can do is quite phenomenal. So he is one of our collaborators. We have our craniofacial team headed by Paul Sharp, who has been growing teeth on rats and mice and whatever, and dentine and regeneration, what have you. So he's been an enormous help. And of course, this work has been with Eileen Gentleman, who is the tissue engineer that that supervises Chris work with myself. So we are at a stage where we have been able to use the hyaluronic acid that I use in patients to make it into a solid enough form that we could put it into a defect. We can get stem cells in there, and it is viable, and it seems to be able to be adhesive to the surrounding tissue. So we are at the stage where really we're quite early. We need to think about the next stage. It's done in the lab. We need to shift it into an in vivo model. So in terms of where we are relative to our peers in tissue engineering of temporal mandibular joint, we have to say there are people who've been working on the temporal mandibular disc, and some of you will be aware of that, and they've already started big animal studies and had some good results. My thought was, it's actually important to ensure that when you are doing some projects that you are able to add to the information. So I didn't see the point of us continuing in that field. Let's add to it. And that's why we started instead on trying to construct a bilaminar of cartilage and bone over the condyle. And hopefully next time we speak, then perhaps I might have some actual in vivo results for you, but we are early on. So we'll have to watch the space, but thank you very much for letting me speak. And I'm going to hand over to my colleague who actually is doing innovative things in the patient, but thank you. These are just some acknowledgements of who've supported Chris during his PhD.
Thank you. Thank you so much, Professor Kathy, for this wonderful innovation which you have done along with that your student. Do we have any questions? I think there is no question in the chat box, so we'll move ahead. Now I'll request Professor Shraddha Singh, ma'am, to kindly introduce our next speaker, Professor Naseem Ghazali.
Thank you, Dr. Anita. Thank you, Dr. Anita. I am audible? Yes. Okay. Again, I am going to use Professor Naseem Ghazali.
Shorter than we have already listened to your introduction, but in short, you may not.
Short, okay. Yeah, in short, I'm going to, okay? Hello. Just first, I would like to give the thanks to organizers. In very short, Divya has told me in very short you have to say this. Professor Naseem Ghazali, who is duly qualified and in dentistry and medicine. Okay? She has completed her maxillofacial surgery training from London, Royal Surrey Country Hospital, Guildford, and Queen Victoria Hospital, East Green Estate. She was awarded a clinical research fellowship in head and neck oncology at Antony University Hospital, Liverpool, She has completed a surgical fellowship in head and neck oncology and reconstructive surgery at the University of Maryland, Baltimore. Professor Ghazali is the leader of Research and Development Maxillofacial Department at ELST. Her research interests are in head and neck cancer, particularly outcomes research, that is, function and quality of life outcomes. She has been awarded with in this area of many projects, and she has widely published as many as 35 peer-reviewed papers and also written a book chapter. She has been invited as a speaker at many places. Her future area is, that is trans-oral robosurgery and oral pre-cancer dysplasia. She has received many professional memberships and also prestigious membership to British Association of the Head and Neck Oncology. So I must appreciate her achievements, and she has developed so many projects and work in this area. So I now invite you for delivering a lecture. Welcome, ma'am. Welcome, Professor Naseem Ghazali. Yes.
Thank you so much. I'm going to try and share my screen. Okay, so I think it's good afternoon over there, ladies and gentlemen, and thank you, Professor Mehrota, for your invitation to speak at this webinar. It's really an honor to be speaking among quite distinguished speakers from the morning. I've caught a few of the speakers speaking, and also really to reach out to an international audience from Blackburn, which is a city in the north of England where I work. My task today really is to speak about innovation from a surgical perspective. I don't have any conflict of interest, and you will see a lot of equipment, a lot of kit that's being part of my lecture, but I don't receive any financial gains, or I'm not part of any of the commercial side of the equipment. Innovation is really the force that drives towards evolution. As surgeons, we mostly try to solve our problems with the work of our hands, and we always want to strive to perform better surgery for our patients. Sometimes in that process, we encounter some technical problems, and they make the surgery difficult, and sometimes we feel that the surgery is impossible. So the need to overcome problems really drives the whole invention and innovation. As a fellow of the Royal College of Surgeons, I think we are all acutely aware of the history of surgery and its developments in Europe and in the UK. We started out as barbers who cut hairs and shaved men. These barber surgeons extended their repertoire with the knife to surgery and really undertook some gruesome kind of surgery at the time of pre-anesthesia. Hence, you get the term barbaric surgery, because barber surgeons were carrying out some gruesome surgery at the time. With innovation through anesthesia and antibiotics and the understanding of aseptic techniques, it allowed the barber surgeons to become, respected, proper surgeons who evolved surgery to something that's safe. And the surgery is conducted open, which means that we cut through the skin into the cavities, into the tissue planes of people. And we were able to do that safely. Then the next thing that came by was optical innovation, and optical innovation allowed to do work endoscopic, which means that we were able to do the same kind of surgery somewhat, but not having to go through open surgery. This is really a massive paradigm shift, because patients no longer needed big incisions that went through and damaged normal tissues, opening body cavities merely just to gain access to the area or the organ that we needed to do the surgery within the body. So patients really benefited tremendously from minimally invasive surgery because they recovered quicker, they experienced pain less compared to open surgery. They stayed in hospital less times, and they developed less amounts of complications. However, doing minimally invasive surgery gives us surgeons some problems. We still had difficulties because the camera was rigid. We couldn't see past corners, and inside the mouth where I work, there are lots of corners, nooks and crannies that and there's shadows, and you can't really see if the camera is rigid. And then we relied on assistants to hold the camera in place while we're doing the surgery. So, assistants can get tired, they can suddenly move. Sometimes assistants fall asleep during surgery. So, it's a bit unreliable. And sometimes the instruments that we use for endoscopic kind of surgery, they're very rigid as well. And it didn't allow the same kind of movements. So the movements were limited and they were unnatural. Okay. So what's happened is that in order to overcome these difficulties, technological advancement in engineering and digital input have moved minimally invasive surgery to the point where the same surgery that has been done openly with big incisions and everything can be done with the same ease and accuracy with robotic surgery. So the introduction of the robotic surgery has allowed us surgeons to further innovate the technical aspects of undertaking the surgery as we know it. This is the robotic platform that I use. It is based on the Da Vinci robotic system. It is the most commonly used robotic system in head and neck cancer surgery. There are other systems that are in place, for example, the Medtronic Flex Robotics, and also recently in the UK, the Vesuvius robotic system. But in head and neck cancer, in head and neck surgery, it is a Da Vinci robot that's the predominant robotic system. So as you can see, the slide shows the three components of the robotic platform. You've got the vision cart, which has the processing capabilities, the electric energy configuration for the surgery, and also there is a screen that allows other people to see what I can see at the surgeon's console. So the surgeon's console is really where I sit and do the surgery. It allows me to see the camera in three dimension. It's got the robotic arms which merge with my hands. So whenever I move, the patient side cart, which is what most people think is the robot, moves exactly the way I want it to move. So I'll be going through the components in the next few slides. So this is the surgeon's console that's sat there. So you can see the robotic arm with the finger clutch. So I put my fingers through that and I can move the arms, and through that there is the robotic system, which is called the master controller. The master controller translates my movements at the robotic arm into, and they scale it down in the robot by 10 times. And also it takes away any tremor that I may have naturally, and the robot completely cancels that. You can see that there is ergonomic control, which allows the changing of the position of the robot, the surgeon's console, so that it fits with my head position. It doesn't really matter how tall or how short you are. I'm pretty short, so in theater most of the time I have to stand on a platform because everybody else is much taller than me. But in this case, I'm very comfortable. The robotic surgeon's console shapes itself to fit me, and I'm very comfortable there. I can put my head into what I call the visor. So the visor has an eyepiece. It allows me to see what the surgical field, which is the camera that's in the surgical field. It's a high definition 3D camera. It magnifies what I see 10 times. So there's nothing quite like seeing, a bleeding artery in the operating field that is magnified 10 times in your eyes. There's also a sensor that tells me, or they can tell whether I'm actually at the console or not. So because once they detect that my head is at the console, then there's automatic speaker, which magnifies my voice when I'm at the surgeon's console, which is usually located quite far away from the patient. So whenever I have to say something to my assistant, who is bedside next to the patient, they can hear what I say quite clearly. So that's the surgeon's console. Oh, sorry, before I go there, there's a foot pedal where it helps me control the camera on the left-hand side. You can see there's a picture of a camera there, so it allows and shift the camera side to side, so that's camera control. I've got the foot control for electric energy equipment that allows me to do the surgery inside the mouth. So you've got the electrocautery in the coag and cutting function. So now we go to the sidecar, which is the robot, if you like. So you can see several models. It's just like cars. You come up with one model and then you have an upgrade. So the one that's furthest to the left is the SI model, which was the original earliest model. Generally, you can see some similarities within the models. It's got 4 arms. So you've got 3 working arms of the robot, and 1 arm is specially for the camera. So you got in the middle the X model, which is what we have in our hospital. We have two of the X's, and then we also have the XI, which is further on the other side. Okay. So just looking into the arms of the sidecar or the robot, you've got the camera, and the camera, like I said, is a 3D high definition camera. It's a laparoscopic 0 degrees and 30 degrees. You can change position, you can change whichever to suit you. It's got a stroboscopy function and also a button that allows immunofluorescence, provided that the immunofluorescence is injected intravenously at the time of the operation. So that helps to identify potential large arteries that sometimes you might be worried in case you cut into and you can't see. The instruments are called endowrists. The diameter is between 5 to 8 millimeters, depending on the model of the robot. So the SI model uses the 5 millimeters, and the models thereafter, the X's and XI, use the 8 millimeters instrument. So this means that the instruments are very small, and they can go into body cavities, particularly through the mouth, without really causing a lot of difficulties. The models that you get on the endowrist varies. It's a multi-functional instrument, so you can have scissors, you can have needle holders, you can have needle drivers, you can have graspers. So you can choose whichever one you want for the particular function you need. In terms of the movement of the endowrist, it is much, much better than the hand-wristed movements. It's supposed to mimic the hand-wristed movements, but it allows more degrees of freedom of movement. And because of that, it's possible for us to actually work in very small and confined places and do movements that are virtually impossible to do with the natural hand. The energy instruments that are on the endowrist are electrocautery predominantly. You can set the electric settings based on what function you want it to do. If you want to cut it quite through the tissues, then of course the energy will be much more. And the coagulation is a bipolar coagulation, so it runs between the 2 blades as it goes through the patient's body. When I actually operate, I tend to do blend the 2 functions together so that it allows me to cut while coagulating effectively without, therefore there is very hardly much bleeding to be seen, unless of course I cut through blood vessels. Otherwise, other robot places can use lasers as well as harmonics in terms of getting the energy to do the cutting for you. But in my hospital, we currently use the electrocautery. So how does the robot interact with me? It is a master and slave relationship. I am the master. The robot cannot do anything at the moment without me actually controlling it. Maybe one day with AI, we might be able to plan the surgery beforehand and upload into the robot. and with navigation navigation technology, it is possible with AI and navigation for the robot to be left to do the surgery on its own. Again, I agree with the previous speaker talking about AI. It's a matter of acceptance by people and humanity, whether they would be happy for a robot to undertake surgery. But I think either way, the surgeon has to be available around just in case there are problems. As you know, in medicine, there is nothing predictable. Okay, so now that you understand what the robotic platform can do, so I'm going to take you through some of the technological or technical, if you like, surgical technical innovation, not equipment technology or anything like that, just talking about surgical technology innovation. So first and foremost, the robotic platform has been used as an alternative to open access surgery. So here's, I'm going to give you some examples. So the area that I work in is predominantly the oral cavity and the area behind the oral cavity, which we call the oropharynx. So the oropharynx, you can't really see very well because it's blocked by a massive big tongue, and you can't see behind the tongue, you can't see the tonsils very well, and you can't see beyond into the back of the throat. So because of that, sometimes in order to, so for example, here's a clinical photo. So let me just show you where we are. So this is the tongue, this is the lower lip, so up here is the upper lip. So this is the palate, and this is where the bit which we call the uvula, when you say ah and it moves, so this, that over there. And here the tonsil. So you can see how difficult it is to actually gain access to remove this cancer. So whenever we try to remove cancer, we would have to remove a 1 centimeter clear margin around the cancer, which we can potentially still see, but sometimes a deep part down here, which is the bottom end of the tonsil, is very difficult to see because it's blocked by this big, massive tongue. So in this situation, what we would normally do traditionally with open surgery is to split the lip. So you make that incision according to the line drawn. You then cut down all the way to through the tissues to the bone, and then you make a cut through the bone. So just remember, all of these tissues are all normal. They're not they're not diseased. So by doing that, you've then cut through the bone, and allowed the bone to be split from the other side and lifted upwards towards the ceiling, so that you can then see the tonsil, which is in that circle over there. So you can see how morbid, how gruesome this surgery is. And this technique has been described in the 1800s, and we still use this technique today in order to get access to a small tonsillar cancer like what I've shown you. So in this situation, this is the most striking example of how robotic surgery can actually change the way we do things. It's a game changer in terms of approaching treatment for something like this. So I'll show you a case. These are scans of an 80-year-old gentleman who has left tonsil cancer. It's P16 negative, which means it's unrelated to the human papillomavirus. And you can see that the scan shows a mass in the side of the throat, which you can't see on the opposite side. So it's on the left-hand side. And in another cut of the scan, you can see that it's enhancing, showing the pathology over there. So I've got a video here, so I'm going to try and see whether we can play this video. So this is what I can see at the console. You can see I'm checking to see the tumor. I'm making some dots there to mark the area of where the resection margin will be. I'm cutting through the tissue, and you can see there's hardly any bleeding whatsoever. I'm cutting down through the pharyngeal wall, and over here we can see quite clearly what we need to do. So I'm now at the side of the wall of the pharynx. You can see we've put a clip, surgical clip there, because we can see the bleeding point. The vessels are so easy to see. There's hardly any bleeding, as you can see. I'm able to see the bottom end here, which is the bit where it's next to the tongue, where it has been previously, I said it's difficult to see, but I can see quite clearly as I'm cutting. I'm making sure that I can't see any cancer that's grossly seen. And I'm now cutting down on the tongue to ensure that I've got good clear margins at the bottom of the tonsil, at the glossotonsillar area. So I'm just joining everything up now. The side in the pharyngeal wall to the back of the to the back of the tongue, as I'm doing that, obviously I'm checking again to make sure that I haven't caught into anything important. So you can see the view is so clear, it's magnified. I've brought my camera into the field to see clearer. And now we're just at the end, we're almost done there. So now I've finished the resection. So I've put it back so that orientation is not disrupted. And you can see I'm actually stitching the wall. And it's quite interesting because the robotic system doesn't allow you to have any haptic feedback, which means I don't have any mechanical feedback from the needle that I'm going to be I've been putting through the tissue. And soon when I'm going to start tying the knots, which is really very important to know the tension in the stitch, because if you pull too hard, it will break. Now, I don't have that feedback that I would normally get with open surgery. So everything is by visual feedback, and it's all about what you can see. So, okay, so I know that I can't pull anymore. So you'll see at the end of this last stitch, I had pulled too hard and you can see it snaps. And that's because we don't have the haptic feedback. So that's one area in the technical or the equipment, robotic kind of innovation that they're working on. They're trying to see how the robotic system can give the surgeon the feedback. So that's me, end of surgery. This patient had the cancer completely excised and has avoided radiotherapy, which can cause lots of side effects. The patient was able to eat virtually the next day after surgery. So that's in itself quite amazing. So having this wonderful platform with an equipment that can allow you to see very, very clearly high definition in 3D and magnified, it is possible for us to undertake very precise surgery, especially when you're not shaking and you can reliably know that you won't accidentally hit anything, because the robot will only do what you want it to do. So I'm going to show you one case. So this is a lady who presented to me because she actually underwent a different surgery. She had an investigation, endoscopic investigation for acid reflux. But during that surgery, she was sedated. And the doctor who was doing that surgery noted that she was snoring, and they thought that they could see a lump in the back of the throat. So she was referred to me. So I undertook a scan, and you can see the scan shows this enhanced area, this lump that looks like a half moon in the wall, the back wall of her throat or the pharynx. You can see that it's bulging into the back of the throat. This is the back of the tongue. So this is at the wall, so it's protruding into the cavity. So it's no wonder when she sleeps that this would flop into there and cause airway obstruction and the sound of snoring. And you can see as well that that's in that view. So what have we done with this? Before we go, I just want to show you in this section, you can see this black little shadow here. So this black little shadow here is actually the internal carotid artery that runs in the wall at the back of the throat. So I just want you to just remember how close this internal carotid artery is. So this internal carotid artery is really important. It's the main blood supply to your brain, how close it is to the lump. So this is my second case in my current hospital when I started the robotic service. You can see that we've cut through the surface. Now you can see how precise the dissection is. We are able to dissect this lump quite cleanly without any bleeding, as you can see. Now you will notice in this area over here, the pulsating carotid artery, internal carotid artery. So like I said, there's nothing quite an experience that's quite amazing to actually see the carotid artery close to you, but knowing where it is, and I can protect it, I can push it to the side while I'm dissecting this tissue. So there's a bit more bleeding in this case because this pathology is highly vascularized. So I've removed it, I'm stopping the bleeding as much as I can using monopolar, and this is bipolar cautery. And finally, we've got some good hemostasis, and we've put a hemostatic agent into it. And you can see that internal carotid artery is still pumping away, and I've not actually caused any injury to it. And again, another round of stitching to ensure that the carotid artery is protected during healing, and so that the patient can eat and drink straight away after the operation. This doesn't really add very much to the operation in terms of length of operation. You can see I can do this operation like I would with an open access to the area. Okay, so you know what, you can move on to the next one. So the second area, if you like, of surgery technique innovation is by using a robotic platform, we are able to undertake scarless surgery. So what I mean by that is, previously we had to do surgery by open access. We would have to make a cut in the neck in order to get into the structures of surgery. But with the robotic system, we can, through the mouth, the transoral access, we can get to these organs without having to make any cuts in the neck or inside the mouth. So that's what I mean by scarless surgery. So this is a case. This technique I've developed here in this hospital. I don't think anybody in the United Kingdom has done this before, but this is relating to the submandibular gland. So the submandibular gland is located, half of it is located in the neck, which is over here. You can see this anatomical diagram showing half of it in the neck, and half of it's inside the mouth, in the floor of the mouth. Generally speaking, the traditional way of removing the submandibular gland, if it was there was a pathology in it, would be to make a cut in the neck, as you can see in that diagram. And it shows by making that cut, you can access the outer part of the gland, and through that you can then remove the inner part of the gland. But this incision is long. It's in an area where it's quite visible. If it's a young lady, you will have a scar there, and keloid scars are quite common in the neck. Also, what's not known is that there is a nerve that runs from here down this way, and it can go down all the way to this area, and it supplies the movement of the lip. So sometimes patients having a benign condition removed from the submandibular gland can develop permanent paralysis. I've got paralysis in my tongue there. Paralysis of the lower lip because the nerve has been injured at the time of surgery. So what we've done is the robot allows us through the mouth, by making an incision in the floor of the mouth and removing this part first, and then pulling this muscle forward to expose the inner parts of the gland and removing it from inside the mouth. So this is the technique that I've developed. So I'm going to show it to you here. So okay, so what I've done is I've reflected the tongue to the other side. I am now making an incision in the floor of the mouth. I can now see quite clearly the important structures in the area. So you can see that there is an important nerve in the floor of the mouth, and is quite close to the duct, which is the tube that connects the glands and opens into the mouth to allow the saliva that the glands produce to open inside the mouth. So dissecting the gland at the front, which is this gland over here, called the sublingual gland. And in order for me to be able to find the nerve and the duct, I need to remove the sublingual gland. So you can see that that is the duct, which is this structure over here. So I've released that. So by releasing that, I can now find the nerve. And I'll show you in a minute where the nerve is. So now you can see the nerve coming into view, which is that structure. So that structure there, yeah. So that's the nerve. So the nerve is now exposed, so I can now protect the nerve by pulling it to the other side. And having done that, I will now proceed to pull this muscle forward so that I can then see the neck part of the gland from inside the mouth. So now you can start seeing that this is the gland coming into view here. And by removing it from inside the mouth, I don't encounter the nerve that moves the lip. So the chance of getting paralysis inside of the face with this surgery is completely obliterated. There is one important facial artery there, which you saw a minute ago. So we could see that quite clearly with the robotic camera. And having done that, I'm now finally doing the last bits of the operation with the scissors, and I'm protecting the nerve, as you can see at the back end of the nerve over there, and removing the last bit of the gland. So the gland is now completely removed. I'm putting the hemostatic agent into the cavity, and we're going to close the wound with some stitches. So that means this lady here has managed to avoid the scar on the face. She had a little bit of temporary numbness of her tongue because this nerve has been slightly, I guess, manhandled, if you like, during the surgery, but that's now recovered, and she's fully recovered. Very happy patient, no scarring. So finally, there's another area, which is that the robotic platform can, the robotic platform can allow us to, I'm sorry, one second. So the robotic platform can allow us to think out of the box. And what I mean by that is I'm going to illustrate a case that I was involved when I was doing my fellowship in Maryland. That's my fellowship director, Josh Lubeck. So we both did this case together. So the X-ray or the scan shows lots of, this should be the mandible, which is the lower jaw. And what you see here is the outer margin of the mandible, and you should see this line go all the way around, coming to the other side, over on this side, and as well as on the tongue side this way. But you can see that the line is not complete, and there are lots of black spots over there. And the reason for that is because the bone is diseased, and you can see that the bone has had to be removed because the bone is basically non-viable, or basically it's dead, because this patient had radiation in order to treat a tonsil cancer in the past. So one of the bad side effects of radiation is that it can cause bone death because it affects the vascularity of the bone, and with time the vascularity becomes further reduced, and to the point where the bone is deprived of its blood supply and it undergoes bone death. So this condition is called osteoradionecrosis. So there's extensive bone involvement by osteoradionecrosis. And because this patient has had surgery in the past, a lot of the blood vessels in the neck have been clipped and therefore not working. So how are we going to replace this jaw if there are no vessels in the neck that we can reattach vessels from a piece of bone that we would normally take from the leg to reconstruct the bone? So that's the problem we have here. So we planned to resect, which means to cut away the diseased bone from there to there. So this is by CAD/CAM planning. We uploaded the patient's scan onto the Mimics software, and with biomedical engineers on the other side of the world, we planned with them, and we said we wanted to remove this from this edge to this edge of the bone. So they've created, customized what we call cutting guides, which have been printed out so that we can then know exactly where we're going to make the cuts. We've also planned to use the left leg fibula bone. And you can see that in order for us to recreate the U shape of the bone, we have to make cuts within the long straight bone of the fibula in order for us to then bring the two edges together. So what we call that osteotomy. So all of that have been planned, and you can see where the marks are made, where the osteotomy needs to be done, so that can help us actually do this surgery. So once we've taken this bone, we normally take the blood supply of the bone. So you can see a shadow of the blood supply that comes with the bone. So it's at this end of the vessel here in the leg that we detach it. So we take this whole fibular bone with the blood vessel, which is then reattached to the blood vessel in the neck. But this is a problem for this patient because there are no suitable blood vessels in the neck for us to do so. So what do we do with this situation? So we thought, okay, let's find some blood vessels in the chest. And so those blood vessels in the chest are called the internal mammary artery vessels. So if we can find it with the robot and then slide it up into the neck from the chest, we can then able to use healthy blood vessels to reattach. So these are the vessels from the chest, which we brought from the neck with the robot. And then these are the blood vessels that came with the bone that we've now cut. As you can see, it's now been reconstructed to make the chin and the jawbone. And we've reattached those blood vessels to the blood vessels from the chest, which are now currently in the neck. So that would allow this piece of bone to have its own blood supply and remain viable throughout the healing. So you can see that that's how it looks inside the mouth. So the skin from the leg and also the muscle, and we've reattached that to the lip. And this is the same patient, and you can see his face is completely normal and symmetrical. He's got a good chin point. And if you look inside the mouth, the flap, which is the tissue, the soft tissue inside, has also healed very well. And you can see that the CT scan, the 3D CT scan that we did post-op also showed the position of the bone exactly as how we had planned it preoperatively. And again, at 2 years post-op, the patient has now had implants placed on the fibular flap that we've just put in the patient's mouth. And on that, there's, the teeth have been built on, and he continues to have good quality of life and remains cancer-free. So this is the amazing kind of work that the robot platform allows us to take. So we're pushing the possibilities, and this is really important for patients because there's no point beating the cancer, but what kind of life do you live when you can't eat and chew and swallow and speak properly? So for me, that's what technology is all about. It's about making patients' lives better by helping us solve the problems that we experience from a surgical perspective in order to deliver what we think we can for the patient's quality of life. Finally, before I sign off, I think the robotic system as well can be used as a unifying technological platform. What do I mean by that? So if you look at the screen, you'll see something that says Tile Pro. So the Tile Pro is a function on the master controller of the robot console that allows different kinds of digital data to be incorporated onto the robot. So it allows us to perhaps use data from scans, use data from special imaging, while we're on the robot to help us deliver much better robotic surgery. So here, I'd like to show you, this is an ultrasound probe. So this ultrasound probe is attached to the ultrasound machine, which can then be attached to the robot through the Tile Pro. And this is endoscopes, which have got narrowband imaging, which allows us to see highly suspicious blood vessel areas that can indicate that what looks like normal mucosa but is actually altered mucosa, and those areas can sometimes be missed if you were to do surgery under white light. So let me show you this video. So you can see the cancer on the wall, the tonsil. So I'm trying to determine where is the best margin. So, and I also want to see by using the narrowband. So I've got the narrowband. So this is the narrowband. It's showing up all these funny blood vessels, and I need to determine how much clearance I need to give the cancer. So the cancer is quite clear being there. Okay, why is it stopped? Okay, so now I'm now determining, okay, that looks fairly normal, so I'm going to make my marks for my margin. You can see under white light, you can't see these unusual blood vessels, but with the narrowband, you can. And I'm doing this on the robot with the help of the narrowband. See as well, this is the view, and this is the narrowband view. So narrowband shines these light, but on this imaging from the actual camera of the scan, Olympus, I can see it better. So now I'm happy with the margin. So as you recall, the internal carotid artery is behind or deep to that lump. So I'm now putting in the ultrasound probe, and now I can tile probe the ultrasound. So the ultrasound here, you can see this is the blood vessel, it's pulsating over here. And this here is the cancer. So really what I want to determine is the depth. And we can measure this with the probe in place, and you can see I'm starting to measure how deep my margins will be on the deep aspect, so that I don't actually accidentally go into the blood vessel. So so that's what this technology can allow us to do this operation safely. So I know that I can see where I'm going, and I can be fairly confident that I haven't left anything behind in terms of cancer in the patient's mouth. So you can see how good and with good assistance, I can ensure that there is no bleeding. Again, that's the tongue side or the bottom end of the tonsil, and we can remove that. So I think you've seen the rest, so I'm just going to carry on. And finally, this is the firefly that I was telling you about, so the immunofluorescence. So this is what you inject into the blood vessels. And after a few seconds of injecting the blood vessel, you press this button over here, and this is what you see. You can see that I've marked the area out with narrowband. It looked unusual, so I'm injecting this narrowband image, this firefly, and you can see that the firefly clearly identifies that area as being a problematic area. So that confirms my suspicion that that is the area of concern that needs to be removed. So in conclusion, I've presented to you the robotic system that we currently use. It is an upgrade to the endoscopic approach in minimally invasive or access surgery. It can provide accurate and precise surgery in the same way that open surgery can, but gives you the advantage of reduced tissue injury, better outcomes for patients. The robotic platform has allowed us to push the boundaries of what surgery can do. We can provide precision surgery, scarless surgery reliably. There are areas where we can further develop. I'm interested in how this new technology is taught to younger surgeons. At the moment, there's only one surgeon at the console that's doing this. And you can see that the view inside the mouth can only be seen through the console. And the side view that other people can see in theater is only 2D, and it doesn't really give you the same kind of experience that you get at the surgeon's console. So I want to see how we can develop existing technology with the data output from the robotic system to be used for example, for virtual reality, for augmented reality. And I think that would be very useful for new surgeons to gain experience quickly, because as I've explained, most of the surgery is by visual input, and there's very little feedback from your hands like traditional open surgery is. So being able to allow younger trainees to see what they're doing or see what the surgeon is doing is, I think, very, very critical. I think ultimately we do what we do for the benefit of our patients, and our patients would embrace the technology provided that we are confident with the technology itself. I'd like to acknowledge my robotic assistant, Joe. I think he has the harder job being at the side of the patient, because he can't really see the kind of view that I see. The instruments that he uses aren't as great as I have in the robotic arm. And also he's a bit of a super nerd, and he's done all the videos in my presentation today. So thank you, Joe. And thank you for allowing me to speak, and I'll be very happy to take any questions. Thank you very much.
I think so.
Dr. Tulika,
I
yes,
think so. Yes.
Come to the end of the session, and I would request you to kindly summarize the positive points which we can take home from today's session.
I think so. It was a beautiful session. All the three speakers, they chose topics which were really innovative. Like Dr. Monica, she talked about the artificial intelligence. I think so. Most of us don't know about it. It's just words for us, because being in this field, we're not exposed to it. But then it widened our horizons and made us understand that it's a different issue which needs to be tackled. And then Dr. Kathleen, she showed us various new innovative surgical aspects. And to top it all, the last speaker, she touched on topics, robotic surgery, which is hardly unknown, and we realize how useful it is. And it is something, it is not a robot, but it is something which we do in coordination. So it's man and robot coming together, the machine coming together to get the best results. So eye-openers, and what I say the last sessions, the videos were beautiful, and you gave us a complete picture of what we needed to know. In fact, even as a layman, it's something really good, and shows the women's are such big entrepreneurs in fields which were previously untouched. And so I would like to thank all the speakers for working so well and delivering talks, and so engrossing and so enriching talks. And we would like to present certificate of appreciation to all the three teachers. And Dr. Anita would like to present the certificates to Dr. Monica Agarwal, I think so, Professor Naseem Ghazali, and she was the last speaker who talked about the robots. And thank you for having such a beautiful talk. And Professor Kathy Fan, that was really interesting. The talk was really interesting. And Dr. Monica Agarwal. Also, the certificate was displayed.
We would like to appreciate your contribution, Professor Shraddha Singh ma'am. Thank you so much, ma'am, for giving us this precious time. And Professor Tulika, thank you so much for coming and encouraging us. Thank you.
Thank you.
Thank you. Okay. Thank you.
Hello, everyone. Good afternoon. I think we would be starting with our next session, and I would like to invite our chairpersons, Professor Punita Manik ma'am, who is head of the Department of Anatomy and Vice Dean College of Nursing, KGMU, and Professor Jyoti Chopra ma'am, who is Professor in Department of Anatomy. Welcome, ma'am.
Thank you, Rameshwari.
Ma'am, can you, I think Punita ma'am will introduce the speakers who would be presenting.
Firstly, Dr. Aditi Kumar is going to speak on it. I am honored to introduce Aditi Kumar, Project Executive Officer. She is currently working as Assistant Vice President for Bio Programs at Startup Incubation and Innovative Center, IIT Kanpur, where she provides a perfect blend of technical, managerial, and organizational skills. She's responsible for scouting for proposal for BIRAC's Biotechnology Ignition Grant through outreach seminar sessions at Education Institute, scouting for quality startups for incubation, grant writing, managing portfolios of all the healthcare startups. She's also managing BIRAC programs, that is Big, Bioness, Sparsh, and Seed, as well as leading Biodesign Center at IIT Kanpur. We welcome you, Aditi, and we are anxiously waiting to hear from you.
Thank you so much, Professor Punita, for such a kind introduction. And I would like to thank Professor Divya Mehrotra. We've been in touch for quite some time now. Thank you so much for inviting me to such an esteemed platform. And without any further delay, I would like to present my talk. I've kept it quite short because, and I've kept it quite light as well, because the last talk was, I'm sure the students especially, they were mesmerized with all those surgery videos and the potential that AI and ML have in healthcare sector. So I hope my screen is visible.
Yes, quite clear.
Yeah, so let's shift the gears, and we would go into a direction which you normally don't read about or discuss. So I'm here to talk to you about the innovation ecosystem that is developing in our country, especially to promote tech-driven startups and what's there in healthcare industry that the the government funding agencies, the other stakeholders have been able to develop so far. So when you talk about the key ingredients of any successful medtech startup, there are only four key ingredients to it. And one is the technology quotient. I mean, you should know what is needed. You should know what is the pain point that the customer or the consumer is going through. Then you should have the right tools to develop your product, say the 3D printers and all of that. Of course, you need to have money, and then you need to have collaboration with various doctors. And since I'm addressing medical students, so for you guys, you need to collaborate with the people from design background, from engineering background, so that you can develop a product that can serve the intended use. So I am Aditi, and I work with the incubation center that is there at IIT Kanpur. And our responsibility, or the main reason of our existence, is to support the four startups that I talked to you about in my previous slide. We help these startups with providing them the technical know-how. We help them with the right kind of funds. We engage them with right kind of mentors, be it from the clinician side or from the industry side. And we are proud to say that during COVID, three of our startups were able to launch three very much needed product. Our startup was able to develop a high-end sophisticated ICU ventilator, and it was developed right from the scratch. We started from the designing up to the sales part. Then another startup developed a smart disinfection chamber, which is installed in Hyderabad AIG hospital. Then one of our startup is also into manufacturing of N95 mask, which can be seen worn by our Prime Minister Shashi Tharoor and all those renowned personalities. So we provide a 360-degree support to anyone who wants to try their hand at developing an innovative product that can serve the society. And we are spread across the sectors, like we are into agriculture, we are into healthcare, we are into clean energy, we are into sustainability. And I primarily look after the healthcare or the bio sector that we have at the incubation center. So like the incubation center is similar to what an incubator does for the premature babies. The incubator provide the right kind of conditions so that the baby can grow. And that's exactly what we do when someone wants to develop a new innovative product, and we provide them with all the infrastructure, we provide them with the financial support, we connect them with the investors, etc. So if any one of you, and nowadays all the startups who are in the healthcare domain, they have a multidisciplinary team. They would have a clinician either as a full-time or as in advisory role. They would have engineers, they would have people from finance background. So nowadays all the good healthcare innovations that have been able to reach up to the market, like they have been able to make some revenues or sales, all of them had a clinical collaborator or someone from the clinician background working full time. So all these startups, we need you guys. I mean, we need young creative medical students so that India can achieve the number one position when it comes down to healthcare innovations. And trust me, we're trying to tap in all the right corners so that we can develop that ecosystem. We really want to beat the US and become number one when it comes down to biomedical innovations. So as you can see, we provide funding support right from 3 lakh rupees, which can go up to 1 crore rupees through various mediums, various schemes. So if you have an idea and you want to develop a product, all you need to do is just come to us, and we will help you out in sorting all other segments that go into the development of any product. We would also help you in building your team, and these are some of the mentors that we have who mentor our medtech startups very regularly. And as you can see, we have got technical mentors from industries, we have got business mentors from various industries who help these startups with raising more funding, and even put them even put fund into the startups. They invest into these companies. I also walk you through some of the technologies that are being developed or have been developed by our startups who are there with us at IIT Kanpur. So as you can see, what you see is a Purti kit, which is primarily, it has been developed by Anna Biomedical, and it is for the patients who have gone mastectomy, and for their rehabilitation, this person has developed the kit. Then we have a company called Bioscan, who is into developing a screening device that can detect any hemorrhage whenever a patient has gone any trauma or has undergone any accident. So you need not to go for a CT scan right away. Using the device, you can just check if the person has the chances of developing hemorrhage or has already developed one. Then we have got this very interesting device, which is a reprocessing system. So I'm sure like most of you know that catheters are reused. So this person, Vikram Goel, has developed a catheter reprocessing system, and Professor Rishi Sethi is also mentoring this startup. Let me tell you, friends, KGMU and IIT Kanpur have a long-standing collaboration. There have been various collaborative projects that have been done in the past, and we're also now coming up with the Biodesign Center, which would be established at KGMU as well as at IIT Kanpur. So yeah, at least the students who are about to graduate, in case you want to try your hand at something innovative and be a part of change maker, you can certainly look at the biodesign program. And yeah, Then Vaishnavi is also with us. She would be, I think, speaking next. So she's developed a pre-eclampsia screening test. Then we have Dr. Diksha Pandey. She is an alumna of KGMU, and she's also part of a project wherein she's trying to develop a vaginal examination device. And she's also got funding through IIT Kanpur. Then we have got Professor from IIT Kanpur is developing dengue detection kit. So these are some of the innovations that are being developed at our incubation center that we have at IIT Kanpur. So I would be happy to answer any of your questions. I kept the presentation very brief so that if any one of you have any questions, I would be more than happy to interact. And whenever whenever you decide you want to do something innovative, you can simply approach us, any one of us, and we'd be more than happy to counsel you or provide you whatever help is needed. So yeah, that is all from my side.
Any questions? Anyone? There are no questions in the chat box as of now.
Okay.
I hope, Aditi, it was an interesting presentation, and it's really motivating as well. And I think maybe the students must be thinking about what they should do and they should be. And you might be getting questions in future, maybe, from the young mind.
Yeah.
Right? I'll now thank you for presenting such a nice and interactive kind of talk.
Thank you.
I request Dr. Jyoti Chopra ma'am to start with the success stories and to invite our next speaker, who is Azil Rasi, NEET Topper 2020. Dr. Jyoti.
Yeah. There is a student questioning. There is a question from a student for undergrads. What are the fostering programs by IIT Kanpur?
Oh yes, so we have got this program called Entrepreneur in Residence, so that's basically a fellowship-based program that we have at IIT Kanpur. So if you want to try your hand at any of the innovative idea, we would give you the fellowship of 30K to up to 50K per month, and we would also provide all the laboratories and the consumables etc to use, so that you can tinker around it and can develop a working model. Once you have the working model, then we give you other follow-on fundings. So Entrepreneur in Residence is the program.
Okay, thank you.
Yeah.
Our next speaker is Azil Rasi. So I feel proud to introduce her because she is from the medical fraternity also, and she is a NEET topper of 2020. And after topping this exam, she joined the master's course in Faculty of Dental Sciences at King George's Medical University, Lucknow. She did her BDS from Tamil Nadu Government Dental College and Hospital, Chennai. And she aims to deliver good quality dental health and care to the public by her clinical skills and experience. Azil Rasi, we are anxiously waiting to hear your success story.
Thank you, ma'am. Thank you so much. Hello, ma'am.
Yes, you are audible, Azil Rasi.
Ma'am, can you enable me for screen sharing?
Yes, screen is shared with you. You may share your screen, Azil.
Okay, ma'am. evening, everyone. I'm just going to share how I reached this place from a very common. I'm also a very common average student, but I will share how I reached this place to my friends.
Ezel, can you are you log in from 2 systems because the voice is echoing? So keep one system and you can start this slideshow.
Good evening. First, to achieve something, everyone will say you have to got some dream, you have to got some goal. Then only we can work for it. So in this preparation for NEET PG, I think like everyone must have a set target before itself. They should know what they want. They should know which college they want, which department they want, like that. Secondly, it depends upon the study environment. It's better we can start preparing for the NEET PG exam during the internship itself. But internship in every college is meant for enjoyment. So personally, I think during our internship period, it's difficult to get a study time. But in this Corona period, it's okay. Interns are getting time, but normally internship is meant to just clear OPD and they get free, and it's we should enjoy, we should take rest. So the study environment, because for me, I spent 1 year for a preparation. My study environment is totally, I will not concentrate on any of the other things. In a whole day, we will spend most of the day for only studying. Then self-motivation. In many of the times during the preparation, only self-motivation will take us forward. How many friends, how many guides, they will guide us, they will motivate us. But at one point of time, there will be no, we will feel that only self-motivation can take forward us. Then experts talk. At difficult time, we have to always watch like any inspiration videos, any videos. It can be even any song videos or any videos which will boost your energy, or anybody's talk which you want to listen, your personal inspiration to follow, that we should frequently watch those type of videos. In preparation for a PG exam, many of us do one wrong thing is we will work harder, sitting late up in night, getting up very early, reading, but we don't know what we are reading, what is going into our mind. So we have to work smart, because preparing for PG is different thing. We need to cover all the subject. That time we have to do some smart work, like we have to include some points. We did not consider all the subjects, we did not consider all the chapters, so we have to work little smart also. Then this times the fear of failure, this comes very frequently to everyone who actually wants a seat, PG seat, because fear of failure comes because we are sacrificing many things. Like we will be away from our home, we will be sacrificing our sleep, we will be sacrificing food at that time. So we will think that we are sacrificing this much, so we will be able to get the result of this. So this is the fear of failure. This will come at most of the time, especially during the exam time, it will be more. So we have to face it and we have to overcome it. Failure is more important. At that time, we should think only the goal, only the final goal. We should think why we started at the first time to reach that goal. We should think about that only. Then regarding preparation, it's simple. It is actually we have to make our everyone individual. We have to make one schedule. It's not the same schedule generalized for all the people. It varies upon individual. So we have to prepare our own schedule and we have to stick to it. It's not like okay tomorrow. We have to stick to schedule what we are preparing. Then there are two ways. One is concept and another is facts and numerical values. Numerical values, facts and all we should memorize. There is no other go. But regarding concepts, like basic concepts, we should be thorough in it. It should not be like I forgot the concept. Concept should be very correct. There should be no problem with those concepts. Then I prefer always first I will read any topic from textbooks only, not directly from any of the MCQ books. Then last minute revision time, our own notes. We should prepare our own notes. That will be helpful for us. Like numerical values in like dental materials, we will have numerical values. Pharmacology, we will have classifications. Those classifications, there is nothing we should memorize. There is no other way. There is no other concepts there. We should memorize those things. So these and all require frequent revisions, and even before exam, these subjects require frequent revisions. And how to overcome saturation. This means at every point of time, we will think we have read enough, we know all the things. It's okay to leave these things. It's okay to take 2 days rest. It's okay to take 3 days rest, like that. To overcome this type of saturation, it's better that we take breaks at adequate intervals. Say in a day, we should take a break at least 2 hours once or 3 hours once. We can't sit for a complete day at a single place. Then how to manage two subjects. We have to always combine one big subject with one small subject, so that both the subjects are covered and both the subjects are covered thoroughly. Whenever you are getting bored with the tough subject, or it is difficult to cover the subject, we can start with the small subject. So we will combine both the subject. It's very easy. And every time when you think we will quit this preparation, or we will see next year, just keep in mind why you started first. That is the important thing. I basically studied mainly from the Pulse, 3 volumes of Pulse. Then CD book for AIMS PGI is actually very good. It helps us to think in a different way. We have to always try solving MCQs by ourselves. Then we should look for the answers and explanations. Then I studied pharmacology from Sparsh Gupta book, and ortho I followed Jitendra Sharan. Then our own notes will help us more than any of these books. Even from Pulse, CD book, everything, we should make our own notes, which will help us. Then on the day of the exam, it's what I did is my guide always told attempt maximum number of questions. And in reading questions, what we our eyes will directly go into the options. Where is the answer? Where is the answer? But we have to first always read the question 2 or 3 times. Then we should think. Then we should search for the answer what we think are in our mind. We should not directly go to the options. That's the mistake we will do. Then the whole paper, at least during the exam time, it should be read at least twice. And then at last 15 minutes or last half an hour, most of the people, even many of my friends will do this. They will change the option in the last 15 minutes. It's actually a wrong thing, I think, because in last 15 minutes your brain will not have anything and no energy. You can't focus on any of the question. Every question you saw, it will be showing like it's wrong, change. So you should not change anything in the last 15 minutes. It's better before first option will be mostly correct. But if you are sure, second time, third time, if you are sure, then you can change. Otherwise, it's better not to change the options in last 15 minutes. Then after the exam, it's better not to discuss about the paper to anybody. Just take rest, keep the books away, and then wait for the result. Then this should be followed for every exam. Like every 3 months, every 4 months, you are giving any mock exam. we can follow these types of tips. So our final exam will be just an exam and not a big deal. So I wish all the best to all my friends and juniors. And I feel very proud to be a part of KGMU, and especially my department. I thank Professor Divya Mehta ma'am for giving such an opportunity. And this is my first talk after I get the rank. So I thank her very much. Thank you, ma'am.
Thank you, Azila Rasi.
Thank you.
Jyoti ma'am, do you want to add something, or should we proceed? I would request Punita. Yeah.
We will.
Good evening.
Jyoti ma'am. Yeah. Yeah, I would request Punita ma'am to introduce the next speaker, please.
It is a privilege to introduce Mrs. Pooja Venkatesh, who is co-founder and co-CEO of Next Big Innovation Labs. She's heading the biotechnology, IP and regulatory efforts at NBIL.
Is she here? Are you here, Pooja? I don't see her.
Hello, I am Ankita. I'll be representing Pooja ma'am here today on the talk.
Okay. Okay. So Pooja is a biotechnologist with a master's degree in business management from Cass Business School, London. Her focus is to create an IP-based value-driven approach to the innovative work happening at NBIL. She constantly interfaces with industry and academia to help NBIL create innovative products in line with industry requirements. She's heading the scientific research activities with a vision to bridge the abyss between transplantable organ requirement and availability. She has been a speaker at Indo-US bilateral workshop on 3D printing solutions for medical devices, and also a speaker at the Innovate Bengaluru launch. She's on the advisory board for the Department of Biotechnology at PES University. She was a part of VIP delegation from India for the OS Biotech Conference. We are honored to have a talk from Mrs. Pooja Venkatesh. I think Anita Gupta is there to speak for her. So we invite Anita to begin your presentation.
Hello everyone, my name is Ankita and I'm a junior bioprinting engineer in Next Big Innovation Labs. And today I'll be sharing the success story of NBIL on behalf of Ms. Pooja Venkatesh. To start with, we are a 3D bioprinting company incubated in Bangalore. We have built our own customized 3D bioprinters and have in-house developed a 3D bioprinted human skin, which is commercially available as InnoSkin HE. Our main aim is to solve the global crisis of organ transplantation using this bioprinting platform. There are a number of reasons for which we have selected 3D bioprinting technology, which can cater to the requisite needs of developing a 3D printed construct, such as precision in cell positioning, enhanced cell-to-cell interaction within the scaffolds, ability to work with multiple cell types in a single scaffold. Suppose we are trying to print a scaffold which will have which will need multiple cell types to be printed at the same time. So this bioprinting gives us that flexibility to use multiple cell types using multiple extruder system into a single, to print it into a single scaffold. Since the whole bioprinting process is automated process, it overall lowers down the fabrication cost and also enables us to upscale the printed scaffold production. Talking about the science behind 3D bioprinting technology, the outline of the process is quite simple. The primary and one of the most important step in the whole process of 3D bioprinting technology is formulating a bioink. For formulation of bioink, we mix the desired cell types along with its growth factors, hydrogels, and the required cell nutrients and form a bioink. Once the bioink is formulated, we are now ready to load it into a syringe. With the help of pneumatic pressure system, the bioink is gradually extruded out of the syringe and deposited on the bed layer by layer in form of the desired scaffold design that we feed into the bioprinter. After that, the 3D printed scaffold is taken out and incubated in a stipulated conditions. And once the incubation is over, the 3D printed tissue is developed and is now ready to be sold to the customers. And the customers can use it for various industrial applications like any cosmetic R&D or pharmaceutical industrial R&D or any other clinical use cases. We as a company have come to this stage with the help of a number of great government bodies who have helped us in funding. They have funded us through IIGP 2.0 grant from DST. We have also received a BIG grant from BIRAT and Idea to POC Elevate grant from Karnataka state government. Currently, we are incubated at Bangalore Bioinnovation Center. We are also supported by Mark Pharmaceuticals and are partnered with them in a couple of projects. Our journey started in the year 2016 with a goal to bridge the gap between the demand and the availability of the transplantable organs. We had registered our company under Startup India and Startup Karnataka in the year 2016, got incubated in the beginning of 2017, in the month of January, at the Bangalore Bioinnovation Center. And from there on, our journey began. In the next slides, I will now cover the next steps that we had taken for the further development of the company. Founding team members of our company are Piyush, Pooja, Alok, and Ratan. All four of them have come from a very diverse background, and with this diverse skill set and their interdisciplinary mindset, they have set a very strong founding level. Here, Piyush and Pooja come from biotech background, and Alok and Ratandeep come from engineering background. They have collaboratively brought together the expertise from their respective fields to this common platform, and which has enhanced the whole bioprinting development. The four primary reasons why we choose to build this in-house customizable 3D bioprinter are firstly, the commercially available 3D bioprinters in the market are very expensive, and it is a little unaffordable by the common researchers or enthusiasts to perform experiments or afford the bioprinter. Secondly, the lack of flexibility in the engineering aspects in the printer. Thirdly, since different hydrogels requires different printing parameters, the printers do not provide that flexibility in the needs. Hence, it becomes very difficult to use those very rigid engineering ecosystem bioprinters. Lastly, the lack of servicing facilities of foreign bioprinters in India makes it more difficult to handle bioprinters in the very first place. Hence, here we come with our own customizable 3D bioprinter and India's first commercially available 3D bioprinter. The primary feature of Trivima are its pneumatic-based syringe microextrusion system. It has multiple extruder head, which helps in gaining high throughput. It has precise temperature control for both bed and the extruder system. Additionally, if we look, we have also pre-installed UV and HEPA sterilization system into the printer, along with the UV and photo cross-linking technologies integrated in the same system. Trivima has been extensively tested on for multiple applications already, and we have performed a number of technical validations over the past few years on the machine. Trivima has been used to successfully bioprint using multiple bioinks containing natural and synthetic polymers both. Considering a low viscous bioink bioprinting, we have also achieved that kind of facility using the same bioprinter by single pneumatic microextrusion method. And in case of high viscous bioinks, precise temperature control of both extruder and bed has helped us to achieve a more stable scaffold construct. NBIL's own patented technology has also simultaneously helped in gaining a more accurate and precise bioprinting. There are a number of countries who have now banned animal testing, and so companies in the market are switching to immediate alternative solutions of animal testing. Currently, the alternatives that are available in market are pig skin, cadaver human skin, 2D skin models, or any 3D cultured skin model. But these models are highly ineffective and they lack that accuracy which is actually required in the analysis. Since the physiological environment provided by these alternatives are not very similar to the actual healthy human skin, the analysis or the results highly differ from the actual accurate results, which leads to more of a false positive and false negative results. Here is where we think our bioprinted human skin comes in picture, which is InnoSkin Etchy, which is built keeping in mind that it should be built in such a manner that they share a similar architecture to that of a human skin. With its ability to scale up in the production line in industrial scale, it is also found that it can lower down the cost of per unit skin sample, hence making it a comparatively cheaper alternative. We have 3 products lined up in the market, in the pipeline. First is InnoSkin Etchy, which is planned to be launched in 2021, which is basically the topmost layer of skin, which is epidermis. Then we have InnoSkin FT, which is planned to be launched in 2022, which will comprise of both epidermis and dermis. And later we have InnoSkin Clinical, which is to be launched in 2025, which will comprise of epidermis, dermis, and hypodermis. How do we prepare our InnoSkin? First, we formulate our bioink using our trade secret biomaterials. Then we load it into our bioprinter and print it using the developed, patented technology in our customizable 3D bioprinter. Later, it undergoes incubation in the stipulated conditions and requirements. And then we finally, once it is incubated, it is finally ready to reach the customers. So talking about the current progress or the progress so far in our company, we are currently performing internal validations for InnoSkin Etchy and are on our way to achieve ISO certification. We have one process patent for developing unique protocol of bioprinting tissues, along with 2 tech patents for precise printing and developing unique cooling mechanism for our 3D bioprinter. We also have developed our own unique trade secret bioink, which is specially formulated for the production of InnoSkin. Talking about this, we at NVIL look at ourselves as a platform where team, tech, and process and patents all form the major foundation of our company, above which the various products and services are developed. Trivima is our first customizable 3D bioprinter, which is launched in 2018, and followed by InnoSkin Etchy, which will hit the market in 2021. And with a focus to build awareness and curiosity about 3D bioprinting among various students, enthusiasts, and researchers, we have also launched Next Big Learning in this October, in 2020 October. The goal for us is to get the therapeutic tissues that will find applications in various clinical setups, but we also believe such a future is only achieved if people from different and multiple interdisciplinary backgrounds come together and collaborate. This is also one of our main drives behind our next step, which is our next big learning platform. Having said about the next big learning platform, I will talk a little bit about the foundation course that we have developed for all the students and professionals altogether. Bioprinting being such a niche domain, it is challenging right now to find any holistic course which gives details of bioprinting technology. Neither in universities or schools this technology has yet been introduced into the curriculum, because of which we find it very essential to reach out to students and teach them about the interdisciplinary aspects that is required in this domain, covering both the engineering and the biological aspects of bioprinting technology overall. The course highlights are, it is a well-structured curriculum. It will be having 7 modules overall, which would start from the basics of additive manufacturing, and then we will go on to heterogeneous cell layering, complex topics. Since it is an online-based course, it is also self-paced. Students and professionals both can find the flexible time and according to their convenient time and schedule, they can take up the course. It's a overall of 30 hours of engagement, which is required, and it's a 1-month course basically. So we have also onboarded some subject matter experts in our course who are helping us to curate the content of the course. We are also providing a community for the participants in the course, for which in which we are giving them the opportunity to interact with their fellow participants and clear their doubts. And also the SMEs will be part of the community, where if they have any doubt regarding any bioprinting method or any doubts regarding the bioink or biomaterial that is required, they can directly shoot their questions to the SMEs in that platform. After completion of the whole course, we are also providing them industrial certificate, which will, along with which they are also getting an opportunity to work in the company in a fellowship manner. The basic pedagogy that we are following in the course is that since there are 7 modules, each module will be having an average of 5 to 6 chapters. In each chapter, after each chapter is completed, they have to answer a review question. Once they have answered the review question, only then their second chapter is opened, and in a similar manner, they can go on and complete the course. After each module is completed, they have a case study and assignment. Since there are 7 modules, so we are providing each case study and assignment after the completion of each module, which is a total of 7 case studies and 7 assignments. So after their case study and assignment is completed, at the end of the 7th module, they will be having a final assessment where they have to answer 50 questions and in a stipulated time. And once that is complete, they can get the certificate. The basic criteria, grading criteria that we have planned for the course is 50% weightage will be given to the final assessment, and the rest 50% will be given to the course participation, assignment, case study, and review quizzes. So I'll be talking a little bit on the topics that we are trying to cover in this course. The basic topics that we're trying to cover would be the fundamentals of both additive manufacturing and bioprinting, which will cover the history of additive manufacturing, the types of additive manufacturing, the types of bioprinting technologies that are currently available in market, the applications of bioprinting technology. Then we move to the engineering of bioprinting, which from where we have started with the initial and foundation of the course, which is we have started with the introduction to cells, tissues, ECM. Then we move on to how do we decide what type of cells are going to be used for what kind of applications. Then we have we have differentiated between what are 3D printers and what are 3D bioprinters. We have also explained in details the bioprinting technologies that are available, which is inkjet bioprinting, laser bioprinting, or pneumatic extrusion methods. So after that, we move on to what are the biomaterials, bioinks, and scaffolds. We have explained we have given an introduction to them on what are biomaterials, what are the advantages, disadvantages of using a biomaterial, and how do you select, and what are the deciding criteria, how do you make a bioink. Those things have been covered in this module. And then next we move on to the interdisciplinary aspects of bioprinting, where we have given the introduction to a slicing software, where basically you design what is required, what kind of scaffold you want to print, and then you slice it into the slicing software. So how do you use that software? We have given them a proper introduction to that. We have also explained in depth what is scaffold-based bioprinting and what is scaffold-free bioprinting. Apart from that, we have covered the different cross-linking methodologies and why is sterilization important for the whole bioprinting process. And last, we have covered the status quo of bioprinting, where we have spoken about what is vasculature, how do we achieve vasculature through bioprinting, what is heterogeneous cell layering, and how can you achieve that. And at the end, we have spoken about the career aspects that a student can look into if they are taking up bioprinting as their career. So the 4 SMEs that are on board with us are Dr. Jayesh Bellade. He's a 3D bioprinting expert and a course advisor. He's from IIT Bombay, and he's advising us in helping us to curate the content and reviewing the questions and all the assignments. Dr. Geeta Manivesagam is a 3D printing and material science expert from VIT University Vellore, and she's also helping us in the same. Dr. Deepak Kalashkar is a biomaterial and biofabrication expert from University College of London, and Dr. Amit Kumar Jaswal is tissue engineering expert from VIT University Vellore. in the latest news, you'll see that there are, it's 2 weeks ago that we had Regenew on board with us on this course. They're a much older company in terms of experience in bioprinting. So they're also on board with us in this course. In this course, they are talking about and sharing their insights on bioprinting and the various career aspects that a student can look into. We believe such collaborations are always very helpful in our overall development and innovation of any field. We look forward for many more such collaborations with eminent institutes and organizations for bringing about innovative, innovative and revolutionary changes in healthcare industry overall. So yeah, this is it, and this is the story of NBIL. Thank you for your patience, and that's it. Thank you.
Thank you for your talk. I would request Dr. Jyoti ma'am to introduce the next speaker, please.
Now we have with us Dr. Vaishnavi Kulkarni, who is CEO and co-founder of Integnus Biotech Private Limited, which was founded in June 2018. And this company is women-led and women-run biotechnology company that is focusing on developing simple and accessible solutions for diagnosing and therapeutics of human diseases. Dr. Vaishnavi Kulkarni holds MSc and PhD degrees from Pune University with expertise in molecular biology, nanotechnology, and 3D mammalian cell culture. She has received, she's a winner of SIIC Social Accelerator 2018 and 19, and was first runner-up at Swissnex AIT Challenge, Women Entrepreneurship and Empowerment Initiative, which was supported by IIT Institute of Mumbai. So we welcome you and invite you to deliver your talk. Dr. Vaishnavi.
Thank you so much, ma'am. That was a very kind introduction. Am I audible?
Yeah, you are.
Yes. So I'm going to give a talk on the more softer aspects of entrepreneurship. Like ma'am has described, I have had my own company for more than a couple of years now. And there are some things which I learned through this journey, which I would love to share with all of you. So the first thing is, how did I begin? Well, the seed of entrepreneurship was sown pretty early during my PhD, where I joined a lab which was doing a lot of applicative research, not the usual basic PhD research that you usually see. So when I joined, I saw that there was an academic industry collaboration, and my lab was actually making nanoparticles and formulations for wound healing for a company based out of Bombay. So that's where I became familiar with the terms. Like there is this kind of a collaboration. There is a bridging gap between academia and industry. You can stay in academia, you can work for the industry, and you can bring out products in the market. So when I joined, this was just the beginning where I learned how the academia goes into patenting. Then you start your clinical studies, and then you hand over this ready-made beautiful technology packet to an industry. And by the time I passed out my PhD, that was in 5.5 years, this product was actually in the market. You could get this product over the counter, S-Gel. And that inspired not just me, but a lot of my peers to get into entrepreneurship. So I'm very proud to say this, and all the credit goes to my mentor and my supervisor, Dr. Paknikar, where out of 8 people of us who joined in that batch, 5 of us have our own companies now. We are well funded. We are doing well. We have employed more than 10 people each in various cases. And being an entrepreneur is a very fulfilling journey. Yes, definitely. It's a steep climb, but the kind of satisfaction that you get out of building something is entirely different. So, like I said, there's going to be no presentation. I just want to walk you through how it was for me starting this journey, what motivated me, what are the challenges, and as a woman, what I faced all these years. So there's no presentation. You're going to have to bear with me. Well, like I said, the seed for entrepreneurship started pretty early for me. Then I had a couple of options. So I had a postdoc. I had an offer from Harvard Medical School, and I had a fellowship which Aditi described a while ago, which was the Nidhi Entrepreneurship Fellowship, which is also a question somebody asked, a student asked a while ago. So it was up to me. Did I want to go for a postdoc, then come back later and start my company, or do I just start my company and then get the experience that I was hoping to get from my postdoc? So, well, I took a leap of faith. I applied for the Nidhi Entrepreneurship Fellowship, and there I started with. It was just an idea. I wanted a diagnostic kit, a handheld kit for preeclampsia. You're all doctors. You know how tricky preeclampsia is, and this passion in me was driven because I had a friend who lost a baby to preeclampsia, and it was life threatening for her as well. And then as we got deeper, we understood there's no good diagnosis of preeclampsia yet, unless and until it develops symptomatically. So me and one of my friends from PhD, Dr. Jyoti, we just started finding out if there was a biomarker which we could, harness and try to catch preeclampsia early. So that was our idea. And we approached another bioincubator in Pune, which is Venture Center. It's a bioincubator like SIIC Kanpur, which also we are a part of. And I told them, see, this is the idea. I want a fellowship. Could you just help me out with it? Then it went through a series of rounds, where I had to defend my idea. Why? How is it possible? What are you going to do that people couldn't do for all these years? How do you bring in something novel into it? And then eventually I could convince the panelists, I could convince the clinicians that yes, this was possible. And there we got our first scholarship. So we started, then we were taught how to do a good market survey, how to have a good foresight, how to have, a business insight. Because coming from a very academic background, you're thrown into the sea. You have to have a nice streamline. This is where bioincubators are very important. They will guide you. They will define your journey the way you can't define it, because you're right in the middle of it. So we were taught market survey, given good business insights, taught how to build business models, and that's how we moved forward. So the next step for us was we got a grant called Nidhi Prayas. So Nidhi Prayas is another small grant which is given to kind of bring your idea into a prototype. So this is another grant which you should look at if you have a prototype. This is for all the students, whoever are listening to this talk. So it might be a small grant. It's a 10 lakh grant, but you can actually, if it's possible for you to build a working prototype of some sorts, then it opens multiple avenues of, getting the bigger grants later. Like what was mentioned previously. So my company also received BIG a couple of years ago. It's the Biotechnology Ignition Grant. The more you validate what you want to build, the more you can convince people, the more you're going to have chances of getting good grants, good bigger grants. So we were fortunate to get the BIG grant. We were also fortunate to get the SIIC Invent Fellowship, the Invent funding from IIT Kanpur. We also have a couple of more grants and funds. And what we have learned is the first climb, like I said, it's always going to be steep. So your journey is going to start from convincing people why your idea is worth investing in. And, it's not just about building a company. It's also about building yourself. Because I remember I am not the same person either as my partner, the way we were a couple of years back. It's a very, very good path to, bringing about a change in yourself. Like I said, softer aspects. You are going to be more confident. You are going to be building something. The kind of joy, the kind of passion that drives you, it's a completely different thing. And it might not sound very conventional. It might not be the usual run of the mill path that we walk. Like ideally, I should have done a postdoc and I should have been somewhere tenured, non-tenured, coming back to India, whatever. But this is a journey worth exploring. And I believe that if any of you, especially clinicians, who you have a better knowledge of the human anatomy, of the physiological aspects of, human diseases, therapeutics, how everything works, there are so many opportunities to collaborate with, say, people like me. I'm a molecular biologist, I'm a nanotechnologist. I have a certain technology, I have a certain expertise which could complement your expertise of, you know, human diseases, human physiology, and we could come up with something so brilliant, and we could come up with, probably we could solve the biggest problems that has been challenging the world for so long. Like in case of COVID, um, like we have come up with so many technologies where there was a good amalgamation of industry as well as academia, especially clinicians. So it's a very good opportunity for you, and you should definitely explore it parallelly with your studies. The second thing is challenges as a woman. Fortunately, I would like to say this very proudly. I, being a girl, being a woman, I have never faced any issues in raising grants, in raising any kind of funding, or getting any kind of mentoring. In fact, I think it's always an advantage to, you know, be a woman in a world full of men. So I want to encourage all of you to take up entrepreneurship. Think about it. It's it's see it's uncharted waters, but like I said, at the end of it, it is quite fulfilling, and the joy of bringing something, conceptualizing, working on it, developing it, and bringing it out in the market is a different joy altogether. So my personal belief is, as doctors, you have a better understanding of the needs that the medical community faces now. So if at all any of the students are thinking of coming into entrepreneurship, I believe it would be a godsend. It would be a marriage made in heaven, wherein you know what needs to be done and you have the power of doing what needs to be done. So I'm just going to keep it short and sweet, and I'm going to wish everybody out there a lot of good luck. Thank you.
Thank you, Vaishnavi.
Thank you, Vaishnavi. And ma'am, you were speaking something. Please continue. I think the next speaker has gone because she had to attend some other meeting, Deepika. So we will be shifting to Ankita Gulati. Jyoti ma'am, please, can you give the introduction?
So now I invite our last speaker, Ankita Gulati, to share her success story. Ankita Gulati is the founder of Touch Vision, which is an inclusive design and technology enterprise which aims to empower 1 billion persons with disabilities globally. Ankita has been honored with National Award for Empowerment of Persons with Disabilities in 2019 by the President of India for Development of Affordable Assistive Technologies. She is serving as the youngest subject matter expert with Rehabilitation Council of India. Ankita has recently been honored with Universal Design Award by National Center for Promotion of Employment of Disabled. Over to you, Ankita. We welcome you.
Thank you so much for having me here. Thank you so much, Dr. Divya, for inviting me here. I'm probably the only non-doctor person over here, somebody who's not from the medical background, a core technology person out there. So yeah, today I'm here to talk about Touch Vision. So I'll talk a little about how we started with Touch Vision. So Touch Vision's primarily core idea or the purpose started around 6 years back in 2015. As a part of my master's thesis, I was pursuing my MTech at that time. And we realized that visually impaired kids cannot study diagrams and geographical areas. They cannot become doctors. They cannot learn about the structure of heart. So they can definitely not become doctors. Why not? Why can't we have alternate professions or technology, engineering, or STEM professions for children with visual impairment? Why can't they dream big? So that's the problem we started solving. So how it started was that I was visiting a blind school and I noticed that children were sitting in a circle and a single map was being rotated among them. And with audio narration, they were supposed to study the map made up of handmade
material and pulses to denote different textures. So they were not able to decipher anything about the graphics. We thought that we will make a technological intervention there which can solve this challenge for children. So I'll be sharing some slides as of now. Yeah, so these were the challenges. I mean, like availability of limited learning resources and recreational activities. We were working with very young kids, and majority of the perception and cognition development happens before the age of 10. So recreational activities also play a major role. Children with disabilities or specifically visual impairment, they cannot go out every time to play cricket or outdoor sports with their peers. So that also leads to exclusion. Accessibility is also another challenge. In India and other developing countries, we don't have any resource for making diagrams accessible for children with visual impairment. But in developed countries, primarily in the Europe and US, we have devices which start from $595, and cumulatively the package costs you $4,000 plus to just access one graphic. So that was clearly not scalable in our country. Apart from that, if I'll give somebody a raised graphic of a raised photocopy of the graphic, then it will not be, they will not be able to perceive what is the content of the graphic. For example, as I'm talking to all the doctors out there, so if the structure of heart is represented on a graphic, you cannot have a tactile photocopy of the same picture and present it to a visually impaired child. So you have to declutter the image and separate it into different image and render simultaneous audio narration with it. So that part of understanding the psychology of a child took 3 years for us, and we have been through 7 prototypes in the last 4 years, and we launched the device last year. Again, the major challenge is that there is a scarcity of special educators. Like the intervention from trained educators is a challenge in India and other developing countries, and there are no independent aids. So what we wanted was that you have an independent system with you. You are a child with visual impairment, you have an independent device with you, and you just plug and play and read anything which interests you. That was the whole concept behind Touch Vision Score product, which is an inclusive audio tactile reading kit. I'll be talking more about it now. Yeah, so there's a short video which explains what it is all about, so that you can get a brief idea of.
Children learn, acquire skills while enjoying in school. But what about visually impaired kids? They lag far behind due to limited learning resources and recreational activities. Braille has served as a great alternative for text, but there is no such alternative for pictures. Touch Vision aims to make pictures accessible for visually impaired kids. Mobile camera tracks finger movement over the tactile graphic and provides audio label and description.
Africa. Africa is the world's second largest and second most populous continent.
Provides interactive games for self-learning.
Let's play the quiz game. 11 minus 7 equals 4.
Storybooks for enjoyment and developing reading habit.
नदी के किनारे एक जामुन का पेड़ था जो पूरा साल फलों से भरा रहता था.
Enables easy exploration of geographical information.
Delhi Metro Map. New Delhi. Plant cell. Nucleus. In cell biology, the nucleus is a membrane-enclosed organelle found in eukaryotic cells.
Let's realize the dream of inclusive education with innovative solutions from Touch Vision. Children learn, acquire skill.
So that's how we started. This is our core flagship product through which we started via mobile device and via tactile book. So as I told you that you cannot have a tactile photocopy, but you can simplify the diagrams and deliver them to children in raised format using different textures. Along with that, we wanted simultaneous audio in a multilingual format, which is more suitable for a multicultural country like India. And at the same time, apart from the language constraints, for us, dissemination and affordability were major constraints. As Android devices are already being disseminated by the Government of India under Sarv Shiksha Abhiyan and under other schemes for persons with disabilities, that's why we decided to go with a mobile app which is accessible to render the simultaneous audio. As of now, we have touched lives of around 20,000 kids with this device across India, US, and Europe. So US market was a very surprising discovery for us. We realized that we were not able to implement the US devices here in India because of the cost constraints. But I went to study at MIT in 2018, and I realized that there exists a huge gap between urban US and rural US, and rural US requires the affordable devices. So that's how we penetrated into US market, and the same with different regions across Europe. As of now, it's helping them in accessing educational content from class 4 to class 10, skill development, different type of storybooks, general symbols, perception development, and it's available in regional languages. So our main aim is to why we said that we want to empower 1 million persons with disability globally. So we started with children with visual impairment, the core product, which I've shown right now. Then we realized even now print is not accessible for people with visual impairment across any age group. So that's how we started developing multiple products to enhance their inclusion in education and employment ecosystem. As ma'am said, that we have also received an award for development of this device. I'll just stop the share and discuss more about why I'm here. So yeah, as you saw that we started with a product which is specifically for schools and independent learning, by hospitals, and why am I here? So yeah, we realized that the school also has to have inclusive infrastructure, that you can have educational content accessible, but if you cannot enter a school building, they're not accessible ramps, pathways. It has to be overall a comprehensive, inclusive environment. So we started working with schools, making the infrastructure accessible, and that's how we went to hospitals. Because the development of this device, why it took 6 years, I was completely from tech background, but the development of anything dealing with person with disability or anybody who has a different psyche than you requires a lot of understanding on the clinical and psychological level. So the Bible which helped us in psychology is called the psychology of touch, and that's how we started working with a lot of doctors. And we realized that the main thing is to make, first step is to make the hospitals accessible, because they are the central point of contact for diagnosis, for getting the certification, and that's how we penetrated, and that's why we became cross disability rather than just focusing on visual disability. And that's why our limitations on why only India market also vanished, because it's a global market for assistive technology. As ma'am said in the last session, that getting grants and other things, yes, it's not difficult for women, but we are never assumed to be somebody who's profit making or who's making a sustainable venture. I mean, people have this assumption about women that they can't make a lot of money, and especially the sector I've chosen. So my whole perspective on personal development as an entrepreneur is that even if Ankita leaves Touch Vision, the work continues. So it has to be sustainable. It has to have money flowing in terms of profits or whatever you call it. That's why it's a private limited. We are incubated at IIT Delhi, our institute where the core technology was developed. And I was talking about other products. So one makes any print accessible for a person with disability on the go. It's being used in banks, hospitals, schools. It's across age groups. And a traditional scanner costs you 3 lakh upwards. It costs you 1,800 rupees. And it's portable. You can carry it in your laptop sleeve, and people are using it. So in COVID, this whole idea of making hospitals accessible, we have received an offshoot on that. And similarly on the devices, making diagrams and print accessible so that children with disability can learn independently, which they can't on Zoom, unfortunately. Yeah. Thank you so much for having me here.
Thank you for giving such a nice section. Yeah.
Thanks, Ankita. Ankita, just to clarify, so your product also takes care of healthcare education, if I'm not wrong?
Yes. So it's like, as I said, from standard 4 to standard 10.
Yes.
So like we have the biology diagrams, the chemistry diagrams, everything is there. So what happened is that few of our users, they have been rejected in India because we have the laws which says that a visually impaired child cannot be admitted to IIT or AIMS, but they have been admitted to top US universities like MIT.
Not that healthcare education, I mean awareness about healthcare in terms of having a good health, general health. So if a clinician wants to communicate to children with disability, can your product be used?
Yes, it can be used, but we are not content experts and we would love to collaborate with you on the content part. We say that we are only technology people. For content, we collaborate with NCRT or content experts or knowledge experts, which are you and not.
Because we deal with children who are special child, we are not able to communicate with them, not able to, without managing their anxiety or their problems, we can't convey what we want to. So maybe products like this can help breaking that.
Definitely. So a little on this part, it's not on healthcare education. So pre-COVID, what we were doing was that we were also making restaurants accessible. So one thing is restaurants and malls. So we have collaborated with Big Bazaar Group for their restaurants and malls. So as you said, that children have anxiety. For example, I'm a child with autism spectrum disorder. Yes. I'm in a restaurant and I want to order something. So it can be a very simplistic interface where child were ordering themselves. Yes. So in similar ways, we can deliver healthcare information through the use of technology.
And secondly,
I would love to get in touch with you.
Yeah. And only autistic or other special children also can be included?
No, ma'am. Now it's cross disability. We started with visual impairment. Due to the limitations in time, I explained about the core product, that how we started, because before this, I had no exposure with disability. Like 6 years back, I knew nothing about Braille or autism spectrum disorder or what disabilities are. That's the disconnect we have. That's how excluded we are from people with disabilities. That's what we're trying to change.
Very, very nice to have you here and here to you. Thank you so much. And I would like to especially thank our chairpersons, Jyoti ma'am and Punita ma'am, for your patient presence during the session. Thank you so much, ma'am, because I can understand as the webinar it goes on and we have fading attendance, and still you all have by your presence have graced the event. So thank you so much, ma'am. So I would yes, ma'am.
We are blessed to be here because it was really a wonderful session, because people from so many diverse platforms, they came at a single portal, and we come to know about their journey, about their journey of success, rather, I would like to say. Because in this session I would like to just summarize the session, because this session, first we have Aditi, right? Aditi, who told us about the bio incubators, how they provided 360-degree support for bioscience innovation. And also she apprised us about the wonderful innovations in the field of diagnostic. Then Azil Rasi, our NEET topper, NEET 2020 topper. She told us about do's and don'ts about preparation of the NEET examination. Then Ankita, on behalf of Pooja, I would like to really congratulate them for developing the first Indian 3D bioprinter. Then we had Vaishnavi, and she shared her entrepreneurship journey and how she developed the handheld kit for diagnosing pre-eclampsia. And finally, Ankita. But I was really impressed, right? She is a founder of Touch Vision, and I would like to congratulate her for developing this economic and assistive technologies for visually impaired individuals. It was really a very mind-boggling type of session and very interesting session.
Divya ma'am, who has searched these jewels, or I don't know how she found them. Seriously, and it's a pleasure to have
this session by saying few lines of Harvansh Rai Bachchan, who said that कोशिश करने वालों की कभी हार नहीं होती, कि लहरों से डरकर नौका कभी पार नहीं होती, नन्ही चींटी जब दाना लेकर चलती है, चढ़ती दीवारों पर 100 बार फिसलती है, मन का विश्वास रगों में साहस भरता है, चढ़कर गिरना गिरकर चढ़ना न अखरता है, आखिर उसकी मेहनत बेकार नहीं होती, कोशिश करने वालों की कभी हार नहीं होती.
Too good, ma'am. Too good.
Yeah, ma'am, I have a query. Yeah, how can I get in touch with you?
Yeah, sure. We'll get in touch with you. Don't worry. We are going to catch hold of you soon, pretty soon.
Thank you so much for having me.
I'll just text you my contact also, so get in touch, sure. So with this, I would like to present a certificate to our speakers for this session. Dr. Rameshwari, are you here? Okay, so Ms. Aditi Kumar, thank you, Aditi. Thank you, Aditi, for your nice presentation. Then Ezil, thank you for that motivational presentation for all our students who are aspiring for NEET. Ms. Pooja Venkatesh could not make up, but thank you, Ankita, for speaking on her behalf. Dr. Vaishnavi Kulkarni, thank you. And Ankita Dulati, thanks a lot for sharing your success stories and your journey which you have all gone through with all our audience. Thank you.
I'm delighted because as somebody from technology background, this is probably the rarest event in which I'm attending with so many women.
So I would also like
to face this gender gap in all the events, but it makes me really happy that there are so many women around there. It's a women-specific event, so yeah, that's very cool.
So thank you, our chairpersons, Professor Punita ma'am. Thank you, ma'am, for your patience, for your listening, for your participation. Thank you, Jyoti ma'am, and the lines were really beautiful, really inspirational. And our moderator, Dr. Rameshwari. Thank you, ma'am, for coordinating this event.
Thank you. Thank you for having me.
I hope the certificates were visible on the screen.
Yeah, it is.
Okay.
Very clear. They were visible.
Yeah. So thank you all again. And I think ma'am, due to some connectivity issues, she's not there. I can see her, but cannot unmute her.
It's okay. It's okay. I think that would be the end of the session and the end of the program.
Yes. Yeah.
Okay, ma'am. You are. She's there.
You can hear. Yes.
Bye.
Okay. Thank you all.
Thank you.
Okay.
Thank you.